Look up at the Great Pyramid of Giza, not as a tourist, but as a traveler in time. See its immense form silhouetted against the desert sky. 2.5 million individual stone blocks, stacked with a precision that defies simple explanation. It stands today as it has for millennia, a silent, colossal question mark carved in limestone, and it asks us, across the vast gulf of 46 centuries, a question that whispers not just from the sands of Egypt, but from forgotten jungles, remote mountaintops, and windswept plains all over our world. How did our ancestors, armed with little more than stone tools, raw human labor, and an unyielding will, achieve the impossible? They left behind no blueprints, no engineering manuals, only the structures themselves, monuments so grand, so perfectly executed, that they continue to baffle our brightest minds and most advanced technology. We live in an age of steel and silicon, of cranes that touch the clouds and computers that can model reality. Yet we are still unraveling the secrets of what they built with copper chisels and rope. This is the great, enduring mystery of our shared human story, a puzzle written not on paper, but in stone. It's a mystery that pulls us back, generation after generation, because the answer speaks to the very core of who we are. It's about more than just architecture or engineering. It's a testament to human ambition, to a drive so powerful it could move mountains, literally. These ancient builders looked at a raw landscape and envisioned something eternal. They coordinated thousands, mastered astronomy, developed complex mathematics, and invented revolutionary techniques, all to leave a mark that would outlast empires, languages, and even memories of their own names. Their legacy is a haunting and magnificent reminder that the human spirit is perhaps the most powerful tool ever forged. This video is an invitation to walk alongside them, to explore the evidence they left behind, and to listen to the stories these silent stones have been trying to tell us for thousands of years. So, we are setting out on a journey to explore 30 of these astounding ancient megastructures, built long before modern tools. From the impossible polygonal walls of Sacsayhuaman in Peru, where stones fit together so perfectly you cannot slip a piece of paper between them, to the subterranean city of Derinkuyu in Turkey, carved 8 stories deep into the living rock, we will travel the globe. We will stand in the shadow of monuments that challenge our understanding of history and marvel at the sheer ingenuity required to bring them into existence. This is a story of forgotten genius, of civilizations whose technological prowess we are only beginning to appreciate. It's a journey into the heart of a mystery that is as captivating as it is ancient, and by the end, you will see these wonders not as ruins, but as a powerful message from our past, urging us to reconsider what humanity is truly capable of. Let's begin our journey with the most iconic of them all, the Great Pyramid of Giza, originally built as a tomb for the pharaoh Khufu around 2500 BC. See, its statistics are so vast they border on the abstract, so let's try to make them real. Picture a structure composed of approximately 2.5 million individual stone blocks, each one weighing on average 2.5 tons. That is the weight of a large pickup truck, multiplied by 2.5 million. If you were to take all that stone and cut it into foot-wide cubes, they would wrap 2/3 of the way around the Earth at the equator. It remained the tallest man-made structure in the world for over 3,800 years, a record of longevity that is almost incomprehensible in our fast-paced modern era. But its sheer mass isn't the only marvel, it's the breathtaking precision with which that mass was assembled. The base of the pyramid is almost a perfect square, with sides that vary in length by less than 0.2%. Even more astonishingly, the 4 sides are aligned almost perfectly with the 4 cardinal directions north, south, east, and west, with an error of just 1/15 of a single degree. Achieving this level of accuracy required a sophisticated understanding of astronomy and geometry, knowledge that we often don't attribute to a society we think of as using only copper tools and human muscle. Now, this level of perfection gives rise to this central, tantalizing question: how was it actually built? The ancient Greeks believed it was done using massive, straight ramps made of earth and brick, rising steadily from the desert floor. This is the image many of us have in our minds, an army of workers hauling blocks on sledges up a vast incline. But the math quickly becomes a nightmare. A single straight ramp tall enough to reach the top would have required more material than the pyramid itself, and its construction would have been a project of equal or greater magnitude. More recent theories propose an internal, spiraling ramp, a corkscrew tunnel built within the growing structure itself, allowing workers to drag blocks upwards along a continuous, enclosed pathway. Others suggest a combination of approaches, a straight ramp for the lower third, and then a spiraling one for the upper reaches. There are even fascinating, if less mainstream, ideas involving the use of water channels and counterweights to lift the massive stones. The truth is, we don't know for certain. No single theory perfectly answers every logistical challenge, and each one has its own set of compelling arguments and frustrating flaws. This is the living, breathing puzzle at the heart of Egyptology. Beyond the physical mechanics of moving stone, consider the human engine behind this project. This was not a project built by slaves under the whip, as popular culture often depicts, but by a highly organized, rotating workforce of skilled Egyptian laborers. Organizing what historians estimate to be 20 to 30,000 people at a time, providing them with food, water, shelter, and medical care, all while coordinating the quarrying, transport, and precise placement of millions of blocks, represents a feat of administrative genius that rivals the engineering. This was a pre-industrial, pre-digital society achieving a level of project management that would challenge many modern corporations. They did this without paper, without telephones, without any of the tools we consider essential for managing a large team. It was done with an intricate social hierarchy, with specialized roles for scribes, overseers, artisans, and laborers, all working in a coordinated symphony of effort that lasted for roughly 20 years. The Great Pyramid, therefore, is more than just a pile of old rocks. It is a frozen moment in time, a perfect snapshot of a civilization at the absolute peak of its organizational and intellectual power. A civilization that could marshal its entire national spirit to achieve a single, monumental goal for its divine king. Now, let's shift our gaze from the sun-baked sands of Egypt to the rolling green hills of the Salisbury Plain in England, where another stone giant slumbers under often gray skies. Stonehenge presents a different kind of mystery from the Great Pyramid. While the pyramid is a monument of overwhelming, singular mass, Stonehenge is a puzzle of intricate assembly and bewildering logistics. Its iconic circle of towering sarsen stones, each capped with a connecting lintel, feels both orderly and profoundly ancient, but the true head-scratcher begins when we ask a simple question: where did these stones come from? The largest of the sarsens stand up to 30 feet tall and weigh a staggering 25 tons each. Geologists have traced their origin to the Marlborough Downs, over 20 miles to the north. Moving a single 25-ton block that distance with only Neolithic technology is a monumental task in itself, but the mystery deepens dramatically with the smaller, inner circle of stones known as bluestones. These rocks, weighing up to 4 tons each, were sourced from the Preseli Hills in Wales, a jaw-dropping distance of over 140 miles away, across rugged terrain and major rivers. The sheer willpower required to conceive of such a project, to quarry these stones in Wales and then transport them all the way to Salisbury Plain, is almost beyond modern comprehension. It forces us to re-evaluate the travel, trade, and cultural connections of these early British societies. So, how did they move these multi-ton monoliths across the landscape? While no written records exist, archaeologists have tested several plausible methods using the tools available at the time. For the shorter journey of the sarsen stones, the most likely scenario involves a combination of wooden sledges, lubricated with water or animal fat, and rollers made from felled tree trunks. Teams of workers would have hauled on ropes, inching the massive stones along a prepared trackway. This would have been a slow, grueling, and incredibly dangerous process. For the epic journey of the bluestones from Wales, the theory becomes even more complex. Many researchers believe our Neolithic ancestors used a mixed-mode transport system. They might have dragged the stones on sledges overland to a waterway, then loaded them onto rafts or lashed them between canoes to float them along the Welsh coast and up rivers, finally returning to a dragging method for the last overland leg. Some experiments have even suggested that the stones could have been encased in wooden frameworks and literally rolled like giant, clumsy wheels. Each of these methods is feasible, but each would have required an immense communal effort, sophisticated organization, and a deep, unwavering belief in the importance of the final goal. Once these stones arrived at the site, the challenge was far from over. Erecting the massive sarsens and then lifting the even heavier lintel stones to perch perfectly on top is a feat of engineering that speaks to a profound understanding of leverage, weight distribution, and simple physics. The prevailing theory involves digging a large sloped hole, maneuvering the stone into position using ropes and wooden frames, and then using a system of levers and counterweights to slowly raise it upright, all while packing the base with stones and timber for stability. To place a lintel on top, they may have built enormous earthen ramps, dragging the horizontal stone up the incline and into position, or perhaps constructed a wooden cribwork that could be gradually raised, layer by layer. What's truly captivating is the precision they achieved. The tops of the standing sarsens were carefully shaped with tenons protruding knobs that fit into mortise holes carved into the lintels, creating a stable, interlocking frame. Even more remarkably, the stone circle is intentionally aligned. At dawn on the summer solstice, the sun rises directly over the heel stone, casting its rays into the heart of the monument. This is not a coincidence, it is a deliberate feature, proof that the builders were not just skilled laborers, but also meticulous astronomers. This celestial connection lies at the heart of the greatest enigma surrounding Stonehenge. What was its purpose? For centuries, it was seen primarily as a temple for sun worship or a precise astronomical calendar, a giant stone computer for predicting solstices and eclipses. This view is powerfully compelling when you stand there at dawn on the longest day of the year. However, more recent archaeological investigations have revealed another, darker layer to its story. The area around Stonehenge is one of the richest and most extensive Neolithic burial landscapes in Britain. Excavations have uncovered hundreds of burial mounds, and analysis of human remains found at the site itself suggests it was a place of interment for a long period, perhaps for a lineage of elite rulers or revered priests. This has led to a fascinating synthesis of theories. Stonehenge was likely not just one thing, but many. It was almost certainly a place of the dead, a sacred cemetery on an epic scale. Simultaneously, it was an astronomical observatory, its alignment connecting the world of the living to the cycles of the cosmos, and it was a place of pilgrimage and healing, as evidenced by the immense effort taken to bring the bluestones from a spiritually significant location far away. It stands as a testament to a complex society capable of grand vision, deep scientific observation, and a spiritual life that was intimately woven into the very landscape they inhabited. From the windswept mystery of Stonehenge, we voyage to one of the most remote and enigmatic places on Earth, a tiny, isolated island in the vast expanse of the Pacific Ocean. Easter Island, or Rapa Nui, is home to the Moai, nearly 900 massive stone figures that stand as silent, brooding sentinels, their backs perpetually turned to the sea. Carved from compressed volcanic ash, known as tuff, at a single quarry inside the Rano Raraku volcano, these statues are a breathtaking display of human determination. The average Moai stands about 13 feet tall and weighs a staggering 14 tons, but the scale escalates dramatically. The largest figure ever carved, nicknamed El Gigant, still lies unfinished in the quarry, measuring a colossal 70 feet in length and estimated to weigh over 270 tons. Using only stone hand tools called toki, teams of master carvers would painstakingly chip away at the volcanic rock, first freeing the front of the statue from the cliff face before undercutting it to detach the back. The level of artistry is extraordinary, with fine details like delicate fingers resting on hips and strong, curved nostrils being added while the statue was still in its birthbed of rock. But the creation was only half the battle. The true, mind-boggling challenge was still to come: transportation. How do you move a 14-ton stone giant for miles across rugged, hilly terrain without the wheel, without draft animals, and without metal? For decades, the prevailing theory was that the Rapa Nui people laid the statues flat and dragged them on log rollers or a wooden sledge. This method, while plausible, presented significant problems, including the immense consumption of the island's precious timber. A more recent and captivating theory, supported by experimental archaeology, suggests the Moai were literally walked to their final platforms. In this method, teams of rope pullers would work in a coordinated, rocking motion, tilting the statue from side to side, while others guided its base forward with each step. When you see a modern recreation of this, it's a surreal and powerful sight. The massive stone figure appears to march solemnly across the landscape under its own power. This method would have been highly efficient, requiring far less wood and fewer people than dragging, but it was also incredibly dangerous. A single misstep could send the multi-ton monument crashing to the ground, where many are found abandoned along the ancient roads. This theory not only offers a practical explanation, but also resonates with local oral traditions that have long stated the Moai walked to their places of honor. Once at their ahu, or ceremonial platform, the final act was to raise the Moai onto its stone base, another feat of leverage and communal strength that completed the long journey from quarry to coast. Now let's travel from the profound isolation of the Pacific to the bustling, chaotic heart of the ancient world Imperial Rome. Here, we find a structure engineered not for quiet contemplation, but for mass public spectacle on an unprecedented scale, the Colosseum. While the Moai represent the focused, spiritual output of a small island society, the Colosseum is the ultimate symbol of a vast, powerful, and technologically advanced empire flexing its architectural muscle. Completed in the year 80 AD, under Emperor Titus, it was a gift to the Roman people, a venue for gladiatorial contests, wild animal hunts, and even mock naval battles. Its sheer scale is staggering. This freestanding amphitheater, built from travertine limestone and Roman concrete, could hold an estimated 50,000 to 80,000 spectators, a capacity that rivals many modern sports stadiums. But its true genius lies not in its size alone, but in the revolutionary engineering that made that size possible and functional. The Romans were master material scientists, and their secret weapon was a revolutionary building material they developed, Roman concrete. Unlike modern concrete, which can deteriorate over decades, Roman concrete has endured for millennia, often becoming stronger over time. Its secret Chinese letter included a special ingredient, volcanic ash, which created a crystalline structure that actually resists microcracks. This incredibly durable material formed the core of the Colosseum, allowing for the construction of its complex vaulted arches and ceilings. These arches were the key to the structure's height and strength. They distributed the immense weight of the building efficiently, allowing for multiple stories to be stacked safely and creating a robust, yet surprisingly open and airy, interior space. This vaulted system also supported the massive stepped seating and formed the network of corridors and ramps beneath the arena floor, known as the hypogeum. This underground labyrinth was a backstage marvel, complete with elevators and trapdoors powered by elaborate pulley systems, used to lift animals, gladiators, and scenery directly into the spectacle above, creating dramatic surprises for the roaring crowd. The Colosseum was more than just a stone bowl. It was a sophisticated machine for entertainment, a testament to Roman engineering prowess that combined material science, architectural innovation, and crowd management on a scale that would not be matched for over 1,000 years. But now, let's journey to a different continent and a completely different environment, where ancient builders conquered not the flat desert or the rolling plain, but the vertigo-inducing peaks of the Andes. Machu Picchu, the lost city of the Incas, is a marvel of location as much as it is of construction. Perched on a razor-shin mountain ridge nearly 8,000 feet above sea level, its very existence seems to defy gravity and logic. The Inca, who built this royal estate or sacred religious site around the mid-15th century, faced a construction nightmare. They were building on a site prone to earthquakes and on steep, unstable slopes. Their solution was a breathtakingly sophisticated stoneworking technique known as ashlar masonry. Each stone, from the smallest block to the massive foundation pieces, was painstakingly shaped using harder stones and abrasive sand to fit perfectly with its neighbors. They didn't use mortar, instead, they essentially created a giant, three-dimensional stone puzzle. The result is walls where the seams between stones are so tight, so precise, that you cannot slide a credit card between them. This wasn't just for aesthetic showmanship, it was brilliant engineering. During an earthquake, a rigid, mortared wall would crack and crumble, but an ashlar wall is flexible. When the ground shakes, the stones in an Inca wall are designed to literally dance, to shift and sway, and then settle perfectly back into place once the tremors subside. They built movement into their structures, an understanding of dynamic forces that feels incredibly advanced. This technique, combined with terrace foundations that stabilize the mountainside and a complex system of drainage to handle torrential rain, allowed Machu Picchu to cling to its impossible perch for over 500 years. It's a testament to the Inca philosophy of working with their environment, of shaping the stone to become part of the mountain itself. While Machu Picchu represents a high-altitude fortress of stone, our next site reveals the ambition of a civilization that mastered urban planning on a colossal scale. In a valley not far from modern-day Mexico City lies Teotihuacan, the City of the Gods. This was not just a ceremonial center. It was one of the largest cities in the entire ancient world, a bustling metropolis that housed over 100,000 people at its peak between the 1st and 7th centuries. In the heart of this city, its overwhelming focal point, is the Pyramid of the Sun. To stand before it is to be humbled. Its base is nearly as wide as that of the Great Pyramid of Giza, a massive mound of earth and stone originally faced with brightly painted lime plaster that would have gleamed brilliantly under the sun. The sheer volume of material used in its construction is staggering. Millions of tons of adobe mud bricks and quarried stone, all moved and assembled by human hands. The methods used to transport this incredible mass remain one of the city's great mysteries, likely involving vast teams of workers using rope, sledges, and sheer numbers to accomplish what seems impossible. We don't even know who built Teotihuacan. The city was already ancient and mysteriously abandoned by the time the Aztecs arrived and gave it its name. Beneath this monumental pyramid lies a secret that adds a profound layer of spiritual meaning to its physical grandeur. In the early 1970s, archaeologists discovered a natural cave and a man-made tunnel system running directly beneath the Pyramid of the Sun, extending hundreds of feet to a point roughly at the pyramid's center. For many ancient Mesoamerican cultures, caves were not just geological features. They were sacred portals to the underworld, wombs of the Earth Mother, and sources of primordial power and water. The deliberate choice to build the city's largest structure directly over this cave suggests the pyramid was far more than a platform for a temple. It was a direct conduit between the human world and the sacred underworld. The entire city's layout reinforces this deep cosmic connection. The main thoroughfare, the Avenue of the Dead, and the positions of the major pyramids are meticulously aligned with celestial phenomena, such as the Pleiades star cluster, and key mountain peaks on the horizon. Teotihuacan was not just a city built for people. It was a vast, physical model of the universe, a sacred landscape where every mountain-like pyramid and every street was designed to mirror the order of the cosmos and connect its inhabitants to the divine forces of creation. Moving from the cosmic city plan of Teotihuacan, we encounter a structure of such immense length that it redefines our very understanding of scale. The Great Wall of China is not a single, continuous wall built at one time, but a sprawling network of fortifications, watchtowers, and barriers, constructed and reconstructed over 2 millennia by multiple dynasties. Its total length, including all of its various branches and natural defensive barriers it incorporates, stretches for an astonishing 13,170 miles. To put that almost incomprehensible distance into perspective, it is a structure long enough to wrap more than halfway around the entire Earth at the equator. This was not a project, but a perpetual national endeavor, a symbol of defense and defiance that evolved with the threats and technologies of each passing century. The earliest walls, built by states during the Warring States period as early as the 7th century B.C., were simple ramparts of tamped earth and gravel, pressed between wooden frames to create formidable barriers. It was the first emperor, Qin Shi Huang, who, after unifying China in the 220 B.C.S., famously connected and expanded these existing walls into a more unified northern defense system against nomadic confederations. However, the most iconic and well-preserved sections we recognize today, with their wide, crenellated ramparts and imposing watchtowers, are largely the legacy of the powerful Ming dynasty, who undertook the most ambitious building campaign in history from the 14th to the 17th centuries. The construction methods for this megastructure were as diverse as its history, a direct reflection of the local environment and available resources. In the western deserts, where stone was scarce, builders relied on a technique using hangtu, or rammed earth. This involved mixing local earth with gravel, lime, and sometimes even sticky rice flour to create a surprisingly durable mortar. This mixture was then compacted layer by layer into movable wooden frames, creating solid, resilient walls that could withstand the harsh desert winds for centuries. As the wall snaked its way eastward into the mountainous regions, the primary building material shifted to quarried stone. Here, the challenge became one of logistics rather than material science. Moving multi-ton stone blocks up near vertical mountain peaks was a Herculean task that dwarfed even the labor of quarrying. Without modern machinery, the Chinese engineers relied on the most abundant resource they had: human muscle. They established human chains, thousands of workers stretching from the quarries to the high ridgelines, passing stones hand over hand in a breathtaking display of coordinated labor. For the largest blocks, they used simple but effective tools like wooden rollers, massive levers, and rudimentary rope pulleys, along with animal power from oxen and donkeys, to inch the materials up precarious, temporary ramps. The mortality rate among these conscripted laborers, soldiers, and convicts was devastatingly high, leading to the wall's grim but fitting nickname as the longest cemetery on Earth, with estimates suggesting hundreds of thousands, if not millions, were buried within its confines. The logistical genius of the Ming dynasty builders is most evident in their standardized production of bricks. In the eastern sections, they established kilns at the base of the mountains to fire countless, uniformly sized bricks. These were far lighter and easier to transport than solid stone blocks, and they could be carried up the slopes by workers, by donkey trains, or even passed along human chains. Once on site, these bricks were laid with a mortar that, like the Romans, demonstrated a remarkable understanding of material science. Recent studies have confirmed that the Ming mortar also included a secret ingredient: sticky rice soup. This organic component created a composite mortar with incredible cohesive strength and durability, a calcium carbonate and amylopectin matrix that has helped the wall resist erosion and even modern bulldozers. The final form of the Ming Wall was a sophisticated military highway. It was wide enough for 5 horsemen to ride abreast, allowing for the rapid deployment of troops and supplies along its length. Its signal towers, placed within visual range of each other, used smoke signals by day and beacon fires by night to relay messages across vast distances at speeds that would have been impossible on the ground. This was not a static barrier meant to simply stop an invasion. It was a dynamic, integrated communications and surveillance system, a nervous system stretched across the spine of a continent, designed to control movement, tax trade, and project the immense power of the Chinese Empire into its most remote frontiers. Now let's transport ourselves from the sprawling length of the Great Wall to the narrow, hidden depths of a desert canyon in Jordan. After walking through the winding, shadowy fissure known as the Sick, a space so tight it feels like a crack in the world, you emerge into the light and are stopped in your tracks. There, glowing in the sun, is the facade of Al-Khazne, the treasury of Petra. It's not built, but revealed, a 2-story high classical masterpiece carved directly into the face of a vibrant rose-red sandstone cliff. The scale is disorienting. The colossal columns, statues, and urns are not added on, but painstakingly subtracted from the living rock. This is architecture in reverse, an act of removal rather than assembly, and it stands as the ultimate symbol of the Nabateans, a desert people who transformed this arid landscape into the heart of a vast trading empire. They didn't construct their greatest monuments, they liberated them from the stone. The method used to create the treasury is perhaps even more astonishing than the final product, because it defies almost every conventional principle of construction. The Nabateans didn't work from the ground up, they worked from the top down. Imagine teams of workers, not building scaffolding to reach the heights, but instead rappelling down from the top of the cliff face on ropes made of hemp and leather. They dangled against the sheer rock, suspended in mid-air, with the canyon floor far below. Their tools were simple but effective: iron chisels, points, and hammers for the rough shaping, and then abrasives like sand for the final polishing and fine detail work. They began by carving out the massive, overarching pediment at the very top of the structure, creating a protective stone roof even before the lower levels were fully formed. Then they would carefully work their way downward, level by level, cutting away the rock to expose the columns, niches, and statues that were hidden within. This top-down approach was not just a stylistic choice, it was brilliant, practical engineering. By starting at the summit, they prevented rock falls and debris from damaging the delicate work already completed below. And the overhangs they created offered natural protection from the sun and occasional rain for the workers beneath them. It was a dance with gravity and geology, a high-stakes process where a single major miscalculation could ruin the entire endeavor. This entire ambitious project was accomplished without the intricate drawings or paper blueprints we rely on today. So, how did they ensure the proportions were perfect and the symmetry was flawless? The prevailing theory is that they used a system of marked ropes and plumb bobs. Master architects likely directed the work from the canyon floor, using measured ropes to mark out the grand dimensions of the facade on the rock face. Workers on the ropes would then use plumb lines, simple weights on strings, to transfer these horizontal and vertical guidelines from the top down, ensuring that every column was aligned and every cornice was level. They were essentially tracing a giant, invisible grid onto the cliff. The carving itself was a multi-stage process. First, the rough shape was pounded out with heavy iron picks. Then, finer chisels defined the architectural elements. Finally, the surface was smoothed and polished with abrasives, likely using wet sand on flat stones to achieve that signature, almost glowing finish. The level of detail achieved while dangling from a rope is simply staggering, from the powerful eagles at the top, symbolizing the Nabatean god Deshara, to the intricate floral friezes and the mysterious, weathered figures standing in the niches. Each of these elements was born from a combination of immense physical courage, extraordinary artistic skill, and a deep, intuitive understanding of stone. The treasury is not just a tomb or a temple, it is a permanent monument to human audacity, a testament to what can be achieved when you look at a mountain and see not an obstacle, but a canvas. High on the Athenian Acropolis, a sacred rock overlooking the city that birthed democracy and philosophy, stands a structure that is the very definition of classical perfection, the Parthenon. At first glance, its appearance is one of serene, mathematical order, a symphony of straight lines and right angles carved from brilliant white Pentelic marble. But that first impression is a carefully crafted illusion. The true genius of its architects, Ictinos and Callicrates, lies in a series of secret, subtle deviations from perfection, optical refinements engineered specifically to trick the human eye into seeing the perfect form that geometry alone could not create. For instance, if you were to lay a long, straight edge along the base of the Parthenon, you would discover something astonishing. The stylobate, the platform on which the columns stand, is not flat at all. It curves upward ever so slightly in the middle, rising about 2.5 inches on the long sides and 2 inches on the short sides. This gentle arc prevents the massive structure from appearing to sag under its own weight from a distance, creating a dynamic, lifelike bulging effect that makes the temple seem to spring from the earth. This deliberate curvature is just one part of an intricate system of visual corrections. Look at the columns themselves. They are not straight vertical cylinders. They exhibit a subtle swelling in the middle, a feature known as intases. This prevents the columns from appearing pinched or concave when viewed against the bright sky, giving them a sense of muscular strength and resilience. Furthermore, the columns are not placed perfectly perpendicular to the ground. They all lean inward ever so slightly, and the corner columns are also diagonally angled. If you were to extend the lines of these columns upward into the sky, they would eventually converge about 1 mile high. This complex arrangement counteracts the visual effect of parallax, making the building appear more stable and solid from a distance, as if it is firmly rooted against any force. Even the spacing of the columns is irregular, with those at the corners placed slightly closer together to appear equal in weight and support when viewed from an angle. Every single element was calculated not for mathematical purity, but for human perception, a stunning acknowledgement that truth in architecture is what the eye perceives, not what the ruler measures. Achieving this level of precision required an equally masterful approach to the raw material itself. The 46 outer columns of the Parthenon were not monolithic shafts, but were built from individually carved drum sections, each one weighing several tons. To shape these drums from the hard pentelic marble, workers used bronze tools, chisels, saws, and drills. Bronze is a much softer metal than iron, which meant these tools would dull quickly and require constant sharpening and replacement. The process was one of immense patience and skill. After a rough block was quarried, masons would use points and heavy hammers to knock away large chunks, before moving to finer chisels to approach the final shape. The final, smooth fluting, the vertical grooves running down each column, was carved after the drums were stacked and secured, requiring the stone carvers to work on a towering scaffold, ensuring that each groove aligned perfectly across the joints between drums. This created the seamless, ridged appearance that makes the column so visually compelling. The entire process was a testament to a society that valued the marriage of intellectual artistry and physical craft, where the philosopher's concept of ideal form was made tangible by the mason's hand. But how did they assemble this marble puzzle nearly 50 feet in the air? The raising of the Parthenon's massive components, the column drums, the heavy lintels, and the sculpted metopes, was a logistical ballet powered by simple machines and organized human labor. The primary tools were wooden cranes, powered by massive wooden winches called capstans. These cranes, likely employing a system of compound pulleys, provided the mechanical advantage needed to lift multi-ton marble blocks with a manageable amount of human or animal power. Teams of men or oxen would walk in a circle, turning the capstan, which wound the rope around a drum and hoisted the load. The Greeks had a sophisticated understanding of leverage and were masters of the winch and pulley, inventions that transformed construction in the ancient world. For the initial stages of construction, especially for the lower courses of the massive platform, earthen ramps were almost certainly used. Blocks could be dragged up these inclines on wooden sledges, a method we've seen elsewhere. However, for the precise placement of the columns and the superstructure high above the ground, the crane was indispensable. The process would have been one of careful coordination. A marble drum swung into position, workers guiding it with ropes, and then masons using levers to make minute adjustments, ensuring the bronze dowels and molten lead pins used to connect the drums aligned perfectly. The entire Acropolis would have been a hive of activity, a symphony of creaking wooden machinery, shouted commands, and the rhythmic sound of stone meeting stone, all dedicated to realizing a vision of divine harmony in marble. Descending from the mathematical perfection of the Parthenon, we travel across the Atlantic to the jungles of Mexico's Yucatan Peninsula, where another civilization achieved its own breathtaking fusion of architecture, astronomy, and numerical genius. Chichen Itza, the great Mayan city, is dominated by a structure known as El Castillo, or the castle, a monumental stepped pyramid that serves as a physical calendar carved in stone. At first glance, it presents itself as a majestic, symmetrical pyramid with 4 grand staircases rising to a solitary temple at its summit, but its true purpose and brilliance are revealed when you understand the numbers woven into its very fabric. Each of the 4 sides has exactly 91 steps. When you add these together, 91 times 4, you get 364. And here is the masterstroke. The final step, the top platform of the temple itself, is counted as the 365th step. This is not a coincidence, it is a deliberate, stunning representation of the solar year. The entire structure is a colossal, climbable almanac, a permanent monument to the Mayans' profound understanding of time and the cosmos. This astronomical alignment goes far deeper than just the step count. The pyramid is precisely oriented so that during the spring and autumn equinoxes, a fascinating play of light and shadow occurs. As the sun sets on these 2 days of perfect balance between day and night, the angled corners of the stepped terraces cast a series of triangular shadows onto the northern staircase. These interlocking shadows slithered down the balustrade, creating the undulating illusion of a massive serpent, descending from the heavens to join its stone head at the base of the staircase. This phenomenon, representing the feathered serpent god Kukulkan, transforms the static pyramid into a dynamic, living symbol of the god's return to Earth, connecting the celestial events with divine mythology in a public spectacle that would have reinforced the power and knowledge of the ruling priests. The pyramid's design also incorporates other celestial cycles. The 9 terraced levels, divided by the central staircase, mirror the 18 months of the Mayan calendar, and the 52 panels on its sides correspond to the 52-year cycle when the Mayan sacred and solar calendars realigned. Every dimension is a number, and every number tells a story of time. Building this stone calculator required construction methods as ingenious as its design. Unlike the solid stone pyramids of Egypt, El Castillo was built using a core and veneer technique. The immense internal volume of the pyramid is not filled with precisely cut blocks, but with a heterogeneous mixture of rubble, rough, uncut stones, limestone chunks, and gravel, all bound together with a type of lime mortar. This method was incredibly efficient, allowing the Maya to create a massive, stable form without the need to quarry, shape, and transport millions of perfect-facing stones. It was a practical solution that conserved immense amounts of labor and resources. Once this core was established and stable, the master masons went to work, facing the entire structure with a beautiful, precisely cut veneer of limestone blocks. These exterior stones were meticulously shaped using harder stone tools, such as dolerite hammers and obsidian blades, to create smooth, flat surfaces and sharp, clean corners. They were then set in place with a thin layer of the same strong mortar, creating the polished, geometric perfection we see today. The logistical challenge of assembling this pyramid without the wheel for transportation or metal tools for cutting was overcome by sheer organization and manpower. The limestone was quarried locally from the surrounding landscape. Without wheels or draft animals, every single block, from the smallest veneer stone to the largest rubble piece, was moved by human effort. This likely involved teams of workers using log rollers, ropes made from henequen plant fibers, and wooden sledges to drag the material to the site. The construction of the pyramid was likely a communal, ceremonial act in itself, a recurring project where each new layer, each new phase of construction, was tied to the celestial cycles the pyramid itself represented. The fact that El Castillo is actually built over a smaller, older pyramid, discovered through a hidden entrance leading to an interior chamber containing a sacred red jaguar throne and a Chakmul statue, speaks to a tradition of renewal and layering of sacred space. Each version was a perfect iteration of cosmic order, a testament to a civilization that saw the universe not as a chaotic place, but as a system of beautiful, predictable cycles that they could literally build into the heart of their city. While the Parthenons celebrated the gods and the Great Wall secured an empire, the next megastructure on our list addressed a more fundamental human need, one that is the very foundation of civilization itself: clean water. The Roman aqueducts were not single structures, but vast, networked systems, the arterial highways of freshwater that allowed cities like Rome to swell to populations of over 1 million people, a scale that would not be seen again in Europe for nearly 2,000 years. To imagine the ancient world without them is to imagine a Rome not of marble and grandeur, but a cramped, insanitary town constantly threatened by drought and disease. These aqueducts were the lifeblood of the empire, and perhaps the finest example of their engineering prowess stands not in Italy, but in the sun-drenched countryside of southern France, the breathtaking Pont du Gard. This colossal 3-tiered bridge is part of the aqueduct that carried water from the springs of Uzes to the bustling Roman city of Nemesis, modern-day Nimes, spanning a distance of over 31 miles. The most iconic segment, the Pont du Gard, soars 160 feet above the Garden River. Its sheer presence is staggering, a layered masterpiece of golden limestone that looks more like a natural geological formation than a man-made construct. But its beauty is purely functional. The top tier, which is the actual covered water channel, or specus, is the reason for its existence. The entire system, from source to city, operated on one simple, yet brilliantly applied principle: gravity. Roman aqueducts did not use pumps. They were designed as a continuously, gently sloping channel, allowing water to flow effortlessly from its source in the hills down to the city's distribution tanks, or casella. The genius, however, lies in the precision of that slope. The gradient of the Pont du Gard aqueduct is a mere 1 in 3,000, meaning it dropped only about 1 foot for every 3,000 feet of length. Maintaining this incredibly shallow, consistent descent over dozens of miles of rolling, unpredictable terrain required surveying and engineering skills of the highest order. Achieving this perfect pitch across a deep river valley required a structure that could maintain the water channel at the exact required height on both sides. This is where the Roman mastery of the arch reached its zenith. The Pont du Gard is a symphony of arches, 6 in the bottom tier, 11 in the middle, and 35 small arches in the top tier that directly support the water channel. The use of the arch was a revolutionary solution to a fundamental engineering problem. A solid bridge of the same height would have been impossibly heavy, demanding a colossal amount of material and exerting tremendous pressure on the riverbanks. The arches, by contrast, are elegantly efficient. They channel the immense weight of the stone and the water above them down through their curves and outwards to the massive piers, which are strategically strengthened against the current of the river. This design creates a structure that is both incredibly strong and remarkably open, allowing wind to pass through and the river below to flow freely, even during floods. It represents a perfect understanding of load distribution, turning brute mass into a framework of calculated strength. Building these monumental arches, high above a river, presented a construction challenge that the Romans solved with temporary wooden skeletons known as centering. For each individual arch, a complex wooden framework was first constructed, its curved shape exactly matching the intended final form of the stone arch. This was an enormous undertaking in itself, requiring the felling of vast numbers of trees and the skilled carpentry to assemble a scaffold strong enough to support the weight of dozens of stone blocks. Once the centering was securely in place, teams of masons would begin the meticulous process of laying the precisely cut voussoirs, the wedge-shaped stones that formed the arch. They started from the bottom on either side of the centering, working their way upward and inward until they reached the top, where the final, central stone, the keystone, was dropped into place. This keystone is the crucial element. Its wedge shape locks all the other stones into position, transferring the compressive forces throughout the entire structure. At this moment, the arch became self-supporting. The wooden centering could then be carefully removed and moved to the next bay, ready to be reused. This methodical, repetitive process allowed the Romans to build spans of incredible size and durability, a technique so effective it would be used for bridges and cathedrals for centuries to come. The stonework of the Pont du Gard is a marvel, but it was another, less visible Roman invention that truly supercharged their hydraulic empire: a special, magical concrete known as opus caementicium, which used a unique ingredient called pozzolana. This was not ordinary sand, but a volcanic ash sourced from areas like Pozzuoli near Mount Vesuvius. When this pozzolana was mixed with lime and water, it created a chemical reaction that resulted in a concrete with properties that seem almost miraculous. Firstly, and most importantly for aqueducts, it could set and harden underwater. This was a game changer. It meant that the Romans could build piers in the middle of rivers and line the entire interior of their water channels with a waterproof, incredibly durable mortar that would not dissolve or wash away. Secondly, Roman concrete was actually stronger and more flexible than modern Portland cement. Over time, it develops a crystalline structure that resists microcracks and actually becomes more resilient with age, a fact that explains why so many Roman concrete structures, from harbor breakwaters to the Pantheon's dome, have survived for 2 millennia, while modern concrete sometimes crumbles after decades. In the aqueducts, this pozzolana concrete was used as the core rubble and mortar that filled the stone walls, binding the entire structure into a single, monolithic unit that could withstand the test of time and the constant, vital flow of water that sustained an entire civilization. From the functional grandeur of Roman aqueducts, we journey now to a spiritual kingdom carved from the jungle, a place where an entire city of the gods was manifested on earth. Deep within the forests of Cambodia lies Angkor Wat, the largest religious monument ever constructed. To call it a temple is an understatement. It is a microcosm of the Hindu universe rendered in stone, a sprawling complex covering over 400 acres, surrounded by a vast moat that symbolizes the cosmic ocean. Its iconic 5 lotus bud towers, designed to represent the peaks of Mount Meru, the home of the gods, rise majestically above the jungle canopy. The sheer volume of material used is almost beyond calculation. The entire city temple was built from millions of sandstone blocks, each one quarried, transported, and fitted with a precision that has allowed it to stand for nearly 900 years. This was the masterpiece of the Khmer Empire at the height of its power in the 12th century, a civilization that commanded the resources and the will to shape a landscape on a divine scale. The origin of this mountain of stone is a key part of the mystery. The primary quarries for Angkor Wat's distinctive grayish-yellow sandstone have been identified at Mount Kilin, a holy mountain plateau located over 25 miles to the northeast. This presented the Khmer builders with a logistical puzzle as immense as the structure they envisioned: how to move millions of multi-ton blocks through dense, roadless jungle and across difficult terrain. Their ingenious solution was to turn the landscape itself into a tool. The Khmers were masters of hydraulics, having engineered vast reservoirs and intricate water management systems for their capital city, Angkor. For Angkor Wat, they created a network of canals that linked the quarries at Mount Kilin directly to the temple site. The process likely began with workers at the quarry using iron chisels and tools to carve channels around each block, freeing it from the bedrock. Once a block was loose, the real magic happened. During the rainy season, the canals would swell with water, becoming navigable waterways. The massive sandstone blocks were then floated downriver on rafts, a method that transformed an impossible overland haul into a relatively efficient waterborne journey. This system allowed for the continuous movement of construction materials, turning the monsoon rains from an obstacle into an engine of construction. Upon arrival at the site, the stones were unloaded and prepared for their final placement. The Khmers did not use mortar in their construction. Instead, they employed a technique that rivals the finest Inca or Greek masonry. The sandstone blocks were so precisely shaped and polished that they fit together with seams often too tight to see, held in place by gravity, interlocking joints, and sometimes by hidden metal cramps. This method required an extraordinary level of skill and planning, as each stone had to be cut perfectly for its specific location in the grand design. The assembly would have been a slow, deliberate process, likely using earthen ramps, elephants for heavy lifting, and complex systems of ropes and pulleys to raise the blocks into position for the towering central prangs. The entire temple complex, with its concentric galleries, libraries, and courtyards, was built to represent the cosmic order, and the precision of its stonework was essential to making that celestial vision a tangible, enduring reality. But the wonder of Angkor Wat is not confined to its grand architecture. It is etched into the very skin of the temple itself. The outer wall of the lowest gallery is home to one of the most breathtaking artistic achievements of the ancient world: nearly half a mile of intricate bas-relief carvings. These are not minor decorations. They are epic narratives carved directly into the polished sandstone walls, depicting scenes from Hindu mythology with a vitality and detail that is simply staggering. Here, you can walk alongside gods and demons in the famous Churning of the Ocean of Milk, a monumental panel showing a line of 88 Asuras demons and 92 Devas gods pulling on the serpent Vasuki to churn the cosmic ocean and produce the elixir of immortality. The scene is packed with motion and drama, from the determined expressions on the figures' faces to the scales on the serpent's body. Other panels illustrate grand scenes from the Ramayana, vast armies marching into battle, and the 37 heavens and 32 hells of Hindu belief. The level of detail is microscopic. You can see the intricate patterns on jewelry, the folds of divine garments, and the individual feathers on celestial dancers. The creation of these bas-reliefs adds another layer to the mystery of Angkor Wat's construction. The carvings were executed in situ, after the sandstone blocks were already perfectly set in the walls. This means the artists were working on a vertical surface with no room for error. Using fine chisels and abrasives, they transformed smooth, hard sandstone into flowing, dynamic scenes of profound spiritual significance. The fact that these carvings remain so sharp and clear centuries later is a testament not only to the skill of the artisans, but also to the exceptional quality of the sandstone from Mount Killen, which has proven resistant to weathering. This fusion of colossal engineering and miniature artistry is what makes Angkor Wat truly unique. It is a monument that inspires awe both from a distance, with its staggering silhouette against the sky, and from inches away, where you can lose yourself in the stories carved by anonymous masters. It stands as the ultimate expression of the Khmer Empire's devotion, a stone scripture dedicated not to a king, but to the god Vishnu, and to the eternal order of the cosmos they believed he upheld. Now let's step further back in time, to the very cradle of civilization itself, the fertile plains of ancient Mesopotamia. Here, in what is now southern Iraq, the Sumerian people erected not just tombs or temples, but stairways to heaven, monumental structures known as ziggurats. And among these, the Great Ziggurat of Ur, dedicated to the moon god Nana, stands as a breathtakingly ambitious masterpiece, commissioned by King Ur-Nammu around the 21st century B. See, this was not merely a building, it was the spiritual and physical heart of the city, a man-made mountain intended to bridge the gap between the earthly realm and the divine. After 4,000 years, its core still rises from the desert, a haunting, massive pyramid of sun-dried mud brick, its corners perfectly aligned with the cardinal directions, a testament to a civilization that laid the very foundations of urban life. The construction of the Ziggurat of Ur was a monumental exercise in logistics and material science, a project that revolved around one of humanity's most humble yet transformative inventions, the brick. The core of the structure, which forms the vast majority of its bulk, was built from sun-dried mud bricks. These were manufactured on an almost unimaginable scale. Enormous teams of workers would mix the local clay from the Euphrates River with water and straw, the straw acting as a binding fiber to prevent cracking, and then pack this mixture into wooden molds. These molds were then left to bake hard under the fierce Mesopotamian sun, creating millions of identical, durable blocks. But the Sumerians knew that the sun-baked core, while strong, would be vulnerable to the rare but devastating seasonal rains. To protect their celestial staircase, they encased the entire exterior in a protective skin of fired bricks. These bricks were cured in kilns, a process that required immense quantities of fuel and labor, transforming the soft clay into a hard, ceramic-like shell capable of withstanding the elements. This two-layered approach, a cheap, abundant core and a durable, expensive veneer, shows a sophisticated understanding of both economics and engineering. Binding this entire mountain of brick together was another ingenious material choice, bitumen. This naturally occurring tar, collected from seeps in the ground, was heated until it became a thick, black, sticky liquid. The builders then used this bitumen as mortar, spreading it between the layers of their fired exterior bricks. This substance was brilliant for several reasons. Firstly, it was completely waterproof, creating a seamless barrier that shielded the vulnerable mud brick core from any moisture that might penetrate the outer layer. Secondly, it acted as a powerful adhesive, helping to lock the bricks into a single, cohesive mass. The logistical effort to acquire enough bitumen for a structure of this scale would have been immense, requiring established trade networks or organized collection from local sources, adding another layer of complexity to this already staggering project. Perhaps the most awe-inspiring aspect of the Ziggurat of Ur is that this entire undertaking, the coordination of thousands of laborers, the production of millions of bricks, the precise calculation of slopes and staircases, was accomplished without a single written blueprint or architectural plan as we would understand it today. The Sumerians, while they did invent writing, left behind no detailed engineering schematics for their ziggurats. So, how was this precision achieved? The project was almost certainly directed by a master builder or a small group of priests and overseers who worked from a shared, meticulously preserved body of knowledge passed down orally and through practical apprenticeship. They likely used simple but effective tools marked ropes for measuring, wooden frames for checking angles, and levels with weighted strings to maintain the structure's perfect alignment and consistent proportions. The design itself, a series of stepped terraces accessed by 3 colossal staircases that converged at a grand gateway, was a well-established religious form. The builders were working within a sacred tradition, reproducing a cosmic ideal on a grander scale than ever before, relying on skill, tradition, and the coordinated might of a society that could marshal its entire population for a project that connected them to their gods. From the soaring brick mountain of Ur, we descend from the heavens to the earth itself, to a desert canvas so vast it can only be truly comprehended from the sky. Etched into the arid pampas of southern Peru are the Nazca lines, a stark departure from every structure we have explored so far. These are not monuments built upward, but artworks carved downward, colossal geoglyphs scraped into the desert floor on a scale that defies belief. Imagine a hummingbird with a wingspan wider than a jumbo jet, a spider larger than a city block, or a winding monkey with a spiral tail so perfect it looks drawn with a celestial compass. These are not mere scratches on the ground. They are figures and lines covering nearly 250 square miles of desert, a gallery of giants that remains one of the world's most profound and perplexing artistic enigmas. The method of their creation seems deceptively simple. The Nazca Desert is a unique environment, covered by a layer of dark, reddish-brown pebbles rich in iron oxide, which have formed a protective desert pavement over millennia. Beneath this dark veneer lies a layer of much lighter, sandy-colored subsoil. The Nazca people, flourishing between 200 B.C. and 600 A.D., created their designs by the physical removal of these dark surface stones. In a painstaking process, teams of workers would clear the pebbles along the predetermined lines of a design, piling them up to form berms on either side of the exposed, light-colored path. This created a dramatic contrast, a sharp, clean line that has been preserved for over 1,000 years by one of the driest and most stable climates on Earth, where there is virtually no rain or wind to erode the carefully arranged stones. The real, mind-bending mystery, however, is not the how of the technique, but the how of the perspective. How did the artists achieve such perfect proportions, such fluid, continuous curves, and such precise geometric alignments when the very scale of their work meant they could never see the full picture from the ground? The prevailing and most convincing theory is one of scaling up a master design using simple, yet brilliant, surveying technology. It is almost certain that the Nazca artists first created small-scale models of their intricate figures, perhaps drawn on cloth or carved into the hard desert ground at a manageable size. To transfer this design to its colossal final scale, they likely employed a system of grids and stakes. A master designer could have subdivided the small model into a series of squares. Out on the vast desert plain, workers would establish a massive, corresponding grid using ropes and wooden stakes, magnifying the model's scale by a factor of hundreds. Each worker or team would then be responsible for clearing the stones within a single, large square of the grid, faithfully reproducing the small section of the design contained in the corresponding square of the model. By working square by square across the entire grid, the overall, gargantuan image would slowly emerge, like a massive paint-by-numbers project etched into the earth. For the immensely long, straight lines that run for miles across the landscape, some of which are arrow-straight, the method could have been even more straightforward. By lining up a series of stakes placed in the ground and sighting along them, workers could create a perfectly straight path over the horizon, a technique still used in basic surveying today. This practical, low-tech explanation demystifies the process, revealing it not as an alien miracle, but as a testament to human ingenuity and painstaking communal effort. Of course, the creation of the lines is only half the story. Their purpose is the other great mystery that has fueled speculation for decades. The most famous and enduring theory, proposed by researcher Maria Reich, who dedicated her life to studying the lines, is that they formed a giant astronomical calendar. According to this view, the various lines and shapes aligned with the rising and setting points of the sun, moon, and significant stars at different times of the year, serving as a celestial observatory for agricultural and ritual cycles. While some alignments do exist, This theory has fallen out of favor with many modern archaeologists who point out that the sheer number of lines means many would align with something in the sky by chance alone. A more recent and compelling theory connects the lines directly to water, the most precious and scarce resource in the desert. The Nazca region sits atop a complex underground aquifer, and many of the largest and most elaborate figures are located precisely over known fault lines, where groundwater would naturally come closer to the surface. In this view, the geoglyphs were not meant to be seen by gods in the sky, but were sacred pathways for rituals intended to appease mountain deities and ensure a vital, continuous flow of water. The figures themselves, the hummingbird, the spider, the monkey, may have been clan symbols or spiritual beings invoked in these ceremonies. The long, straight lines could have served as processional routes, guiding pilgrims from the surrounding foothills to ceremonial centers where these vital rites were performed. This leads to the most captivating question of all. If the lines were ritual pathways, who were they meant for? The traditional view is that the Nazca themselves were the intended audience, walking the lines as part of their spiritual practice. However, a fascinating and more controversial theory suggests the primary audience was not on the ground at all, but in the sky. Some researchers propose that the Nazca people could have experienced their own creations from above by constructing simple hot air balloons. Experimental work has shown it was possible, using materials and technologies available to them, such as woven fabrics and fires fueled by local materials, to create balloons capable of carrying 1 or 2 people aloft. This would have allowed priests or leaders to ascend and observe the perfection of the designs during rituals, a breathtaking spectacle that would have profoundly reinforced their spiritual power. While evidence for this is circumstantial, it offers a poetic and plausible bridge between the earthbound creation process and the skybound final product. Ultimately, the Nazca lines stand as a powerful reminder that a megastructure does not need to reach for the clouds to be awe-inspiring. They represent a different kind of ambition, the ambition to impose order and meaning on a vast, empty landscape, to create a sacred map so large it could only be fully read by the gods, the constellations, or the human imagination. But for a civilization that reached such artistic heights, the mystery of its disappearance is as profound as its creations, around 2500 BC. At the very peak of their architectural achievement, the temple builders of Malta vanished. The temples show no signs of violent destruction, no evidence of invasion or massacre. They were simply and deliberately abandoned. The great doors were sealed, and the islands were left empty for centuries, the temples standing as silent, empty shells until new peoples arrived. This complete societal collapse presents one of history's most haunting cold cases. What could have caused a thriving, spiritually rich culture to simply cease to exist? The most compelling theories point to an environmental catastrophe. Overpopulation and intensive farming may have led to severe soil erosion, stripping the islands of their ability to produce enough food. This fragile situation could have been pushed over the edge by a prolonged, devastating drought. When the rains failed, the land would have turned to dust, and a society concentrated on these small islands with no means of escape would have faced famine and social disintegration. Another theory suggests a powerful earthquake or a sudden climatic shift, but the lack of damage to the temples makes a single cataclysmic event less likely. The truth is, we may never know. The end of the temple period in Malta serves as a sobering, ancient reminder of the fragility of even the most advanced societies when pushed beyond the limits of their environment. These megalithic temples, therefore, are more than just architectural wonders. They are a poignant monument to a lost people, a testament to their genius, their faith, and their ultimate, silent fate. And now we journey to a tomb, not of a pharaoh under a pyramid, but of an emperor buried beneath a mountain, guarded by an army of clay. In 210 BC, China's first emperor, Qin Shi Huang, the unifier of the warring states and the man for whom the nation is named, was laid to rest. His mausoleum complex was a microcosm of his empire, complete with palaces, treasures, and a subterranean universe. But his most stunning legacy, only accidentally discovered in 1974 by farmers digging a well, is the Terracotta Army, a vast, silent legion of thousands of life-sized soldiers, horses, and chariots, all standing in battle formation, ready to defend their ruler for all eternity. This was not a monument for the living to admire. It was a functional military force for the afterlife, a display of power so absolute that it sought to conquer death itself. The sheer scale of this undertaking is staggering. The excavated pits contain an estimated 8,000 soldiers, 130 chariots, and 670 horses, with more figures, including acrobats, bureaucrats, and musicians, still buried in other parts of the vast complex. But the true genius of the Qin dynasty artisans lies not just in the numbers, but in the revolutionary production method they perfected. This was not a project of individual artists painstakingly crafting each soldier from start to finish. Instead, the Qin established what may have been history's first large-scale, state-sponsored assembly line, a system of mass production that would not be seen again until the Industrial Revolution over 2,000 years later. The entire operation was a masterpiece of organization, breaking down the immense task of creating an army into manageable, standardized steps. Different imperial workshops specialized in different components. One workshop would produce nothing but legs, solid pillars of clay designed for stability. Another would focus on torsos, created in two basic shapes, armored and unarmored, using molds to ensure a consistent form. Arms and hands were also molded separately, posed for specific actions like holding a weapon, drawing a bow, or gripping chariot reins. Once these basic parts were leather hard, the real magic of assembly began. The separate components' legs, torso, arms were joined together. The artisans then applied a fresh layer of wet clay, smoothing over the seams and beginning the process of individualization that makes the army so breathtaking. This is where the factory model gave way to an artist studio. Using simple tools like wooden paddles, knives, and styluses, the craftsmen transformed the standardized torso into a unique individual. They added details like armor plates, which could be laced or riveted, and carefully sculpted the folds and tassels of uniforms. But the most remarkable feat of all was the creation of the faces. While the basic shape of the head may have started from a mold, every single face was hand-sculpted with an astonishing variety and realism. Artisans added coils of clay to form ears, noses, eyebrows, and lips, shaping each feature with a few deft strokes of a tool. The result is a breathtaking gallery of humanity. You see young, eager recruits with smooth cheeks, grizzled veterans with stern, lined faces, officers with an air of confident authority, and cavalrymen with distinctive tribal features. There are wide faces, long faces, high cheekbones, and thoughtful expressions. This incredible diversity suggests the sculptors may have been modeling the army on the actual, multi-ethnic soldiers who served in the real Qin military, creating a true portrait of an emperor's power. After the sculpting was complete, the figures were dried and then fired in enormous, bone-chillingly hot wood-burning kilns. Mastering the firing process for such large, thick clay objects was a technological triumph in itself. An uneven temperature could cause a figure to crack or even explode, and the success rate was incredibly high, a testament to the kiln master's skill. Finally, the cooled terracotta figures were painted in vibrant, lifelike colors. Analysis of paint fragments shows they used a rich palette of mineral-based pigments, deep reds, blues, greens, purples, and whites. A soldier would have had a painted face, detailed armor with colored laces, and a uniform in a specific hue, making the assembled army a brilliantly polychrome spectacle, a far cry from the uniform earthen brown we see today. This final, colorful layer, now mostly flaked away, completes the picture of an endeavor that combined brutal industrial efficiency with profound artistic sensitivity. The terracotta army stands as a testament to one man's epic ego, but also to the anonymous genius of thousands of artisans, potters, and project managers who executed a vision of immortality on a scale the world had never seen. It is a frozen moment of bureaucratic and creative power, an army of individuals forever standing watch, not over an empire of the living, but over the eternal rest of the emperor who forged a nation. From a tomb guarded by clay soldiers, we now journey to a palace complex that served as the beating heart of an empire, a place designed not for the dead, but for the living glory of a king of kings. Carved into the foot of a mountain called Ramat, the Mountain of Mercy, in modern-day Iran, lies the spectacular ruin of Persepolis. This was the ceremonial capital of the Achaemenid Empire, founded by Darius the Great around 518 B.C., and it was conceived on a scale intended to humble every visitor. Before a single column was raised, the Persian engineers had to create its very foundation, a feat in itself. They constructed an immense artificial terrace, a giant podium of stone that juts out from the mountainside. This platform, measuring over 450,000 square feet, was built from massive blocks of limestone, fitted together without mortar and often secured with metal clamps, creating a perfectly level stage upon which the drama of imperial power would unfold. It was a deliberate statement of control, a demonstration that the Persian king could command the very landscape to conform to his will. The approach to this royal stage was designed to be a procession of awe. Visitors would ascend via two grand, symmetrical staircases, each with 111 shallow steps, so generously proportioned that they could be climbed on horseback. These were not mere functional access points, they were a psychological ramp, building anticipation and reinforcing the elevated status of those at the summit. The stairs themselves are a masterpiece of design, their gentle incline and wide treads allowing for a ceremonial, stately procession of ambassadors, tribute bearers, and soldiers, all moving toward the audience with the empire's absolute ruler. And lining these stairways, setting the tone for what was to come, are the famous reliefs that make Persepolis so unique among ancient sites. Here, carved into the stone with exquisite detail, is a frozen parade of the empire itself. We see representatives from all 23 subject nations, each identifiable by their distinct ethnic features, hairstyles, and clothing. There are Medes in their round caps, Elamites in their long robes, Armenians bringing precious vessels, and Ethiopians presenting exotic animals like giraffes. This was not a depiction of conquest in the brutal Assyrian style. It was a celebration of a vast, multicultural empire, a harmonious procession of diverse peoples united under the benevolent rule of the King of Kings, each bringing their unique gifts for the Nowruz, the Persian New Year festival. Passing through the monumental gate of all nations, guarded by colossal, human-headed winged bulls known as lamashu, a visitor would finally enter the heart of the complex. The centerpiece was the Epidana, the great audience hall of Darius and Xerxes. Its name translates simply to the palace, but its scale was anything but simple. This hall was supported by 36 towering stone columns, each soaring 65 feet into the air, arranged in a grid that created a vast, open space capable of holding thousands. To stand in the Epidana today, amidst the fallen giants, is to feel a profound sense of scale. But it is the capitals of these columns that truly showcase the unique artistic vision of the Achaemenids. They are not simple, abstract shapes. Instead, they are breathtaking sculptures, taking the form of double-headed animals, bulls, griffins, or lions set back to back. These majestic creatures, with their intricately carved musculature and stylized features, would have borne the immense weight of the cedarwood ceiling beams on their heads and shoulders. The effect must have been overwhelming, creating a forest of stone where the roof appeared to be magically suspended by mythical beasts, a symbolic representation of the king's power to command both the natural and the supernatural worlds. Creating this forest of stone was a monumental undertaking that began many miles away. The limestone was quarried from nearby mountains, most notably from a site known as Mount Hassin Ka. Using iron chisels, points, and heavy hammers, workers would first carve deep channels into the bedrock to isolate a single block. Then they would drive dry wooden wedges into pre-cut slots along these channels. When the wedges were soaked with water, they would expand with tremendous force, cleanly splitting the block from the mother rock. This ingenious technique allowed them to extract massive stones with remarkable efficiency. Once freed, the rough blocks were dragged on sledges, likely by teams of oxen and laborers, to the construction site at Persepolis. There, master stonemasons would begin the long process of shaping. Using a variety of iron chisels, from broad blades for rough work to fine points for detail, they would transform these raw blocks into the perfectly cylindrical column drums and the exquisitely detailed reliefs and capitals. For the final polishing, they would use abrasives like sand, sometimes mixed with water, to achieve the smooth, gleaming surface that would have reflected the bright Persian sun. Raising these 65-foot columns, each composed of multiple, multi-ton drums, was the ultimate challenge. The Persians, like the Greeks after them, relied on the brilliant application of simple machines, the ramp and the lever. The most widely accepted theory involves the construction of massive earthen ramps that rose steadily alongside the growing column. Workers would drag the heavy stone drums up these ramps on wooden rollers or sledges, using ropes and sheer manpower. Once a drum was positioned directly over the one below, the true precision work began. Using a system of levers, crowbars, and likely wooden wedges, the workers would painstakingly maneuver the drum into its exact final position. To ensure stability and alignment, the centers of the drums were often connected with a metal pivot or dowel set into a lead-filled hole, creating a strong, flexible joint that could withstand earthquakes. As each new drum was added, the earthen ramp would be built higher, enveloping the column until the very top was reached. Once the final capital, the double-headed bull or griffin, was securely in place, the entire ramp would be carefully dismantled, revealing the finished column standing tall and free, a testament to the power of coordinated labor and ingeniously applied physics. This painstaking process, repeated dozens of times, resulted in an architectural space that was designed to overwhelm the senses and leave no doubt about the might and sophistication of the empire that built it. High in the sacred valley of Peru, perched on a steep mountainside with a commanding view of the Patacancha River, lies a fortress that seems to defy both gravity and logic. Ollantaytambo is often described as a masterpiece of Inca architecture, but to merely call it a fortress is to overlook the profound puzzle it presents. Its most awe-inspiring feature is the Temple of the Sun, a complex of 6 colossal pink rhyolite monoliths, each standing over 13 feet tall and weighing more than 50 tons. These stones are fitted together with a precision that has become the signature of the Inca, seems so tight that the boundaries between individual blocks are nearly invisible to the eye. But the true story of Ollantaytambo's grandeur is not written solely in the walls that stand, but in the stones that fell short of their destination. Scattered along the ancient route from the quarry to the summit are the silent witnesses to this Herculean effort, the legendary Piedras Cansadas, the tired stones. These abandoned monoliths are more than just unfinished business. They are a frozen moment in time, a snapshot of an immense logistical operation interrupted. The quarry from which these stones originated lies on the other side of the valley, across the turbulent Urubamba River and nearly 3,000 feet up the opposite mountain slope. To stand beside one of these tired stones is to feel a sense of shared exhaustion. They are colossal, inert, and forever rooted in the earth, offering a tangible connection to the immense human struggle that defined their transport. They tell us, without a single written word, that the construction of Ollantaytambo was a battle against the landscape itself, a battle that was sometimes lost. Each one marks a point where human endurance met its limit, or perhaps where a rope snapped, a ramp failed, or a decision was made to abandon a particular block in favor of another. They are the most honest part of the entire archaeological site, revealing the raw, unedited effort behind the polished perfection of the final temple walls. The journey of a single one of these stones from the Cachacata quarry to the construction site is a story of epic proportions, a feat that required an almost supernatural level of coordination and ingenuity. The first challenge was simply getting the multi-ton blocks down the steep slope of the quarry mountain. The Inca engineers likely carved smooth, prepared pathways, and then used a system of ropes to carefully lower the stones, controlling their descent in a delicate dance with gravity. Once at the base of the mountain, the even more formidable obstacle of the Urubamba River awaited. How do you move a 50-ton stone across a fast-moving river without bridges capable of bearing such weight? The prevailing theory is as brilliant as it is simple. They may have diverted the river itself. By building temporary canals or altering the river's flow for a season, they could have exposed the riverbed, allowing workers to drag the stones across the dry ground. Alternatively, they could have constructed massive, reinforced rafts, using the river's current to their advantage to ferry the stones across, a method that would have required incredible skill to prevent a catastrophic capsize. After crossing the valley floor, the final and most grueling phase of the journey began, the ascent up the steep terraces to the building site at Ollantaytambo. This is where the famous earthen ramps came into play. Archaeologists have identified the remains of these ramps, vast inclines made of compacted earth and stone that created a manageable, if back-breakingly long, slope up the mountainside. Teams of hundreds, if not thousands, of laborers would have hauled on thick, braided ropes made from leather and native grasses. The stones were likely placed on wooden sledges, and the entire operation would have been a symphony of coordinated effort, directed by overseers using whistles or drums to synchronize the pull. The workers would have inched the megaliths upward, a process of immense strain that could have taken weeks for a single stone. The presence of the tired stones along this route suggests that even this sophisticated system had its breaking point, a testament to the sheer ambition of the project. Beyond the physical mechanics, Ollantaytambo's strategic placement reveals a mind that thought in both practical and sacred terms. It was not just a fortress, it was a tambo, a royal estate that included temples, residential sectors, and immense agricultural terraces. Its location guarded the entrance to the Antisuyu, the jungle region of the Inca Empire, making it a crucial military choke point. But the Incas never separated the military from the spiritual. The Temple of the Sun, with its gargantuan stones, was positioned with precise astronomical alignments, likely related to the solstices. Furthermore, the choice of pink rhyolite from a distant quarry, when perfectly good stone was available locally, suggests the stone itself held a sacred significance. The entire site is a manifestation of the Inca philosophy of dominating and harmonizing with the landscape, of reshaping the earth to reflect their power and their cosmic beliefs. Ollantaytambo, therefore, is more than its walls. It is a complex document of engineering, warfare, and state religion, a place where the stones, both the tired and the triumphant, tell a story of an empire that could move mountains, but whose greatest monuments still whisper of the human cost required to make them stand. But now, let's leave the mountaintops and the sprawling plains behind and descend, deep underground, into a world of profound silence and darkness. On the Mediterranean island of Malta, buried beneath the unassuming streets of the town of Paula, lies a discovery so unique that it stands alone in the archaeological record, the Hal-Saflieni hypogeum. This is not a structure built upward, but one carved downward, an entire subterranean temple complex hewn from the solid Globigerina limestone bedrock. Imagine a sacred world existing entirely below the surface, a multi-leveled labyrinth spanning 3 stories and covering over 500 square meters, all created by a Neolithic people using only the most basic of tools, stone picks, flint blades, and the antlers of red deer. The sheer ambition of this project is staggering. It is a testament to a society that directed immense resources not toward monuments for the living to see, but toward a hidden, underground realm for the dead and the divine. The construction of the hypogeum is a mystery that begins with the very act of excavation. Working by the faint, flickering light of stone lamps fueled with animal fat, these ancient builders had to first visualize a complex, multi-level structure in their minds, and then execute it with perfect precision in near-total darkness. Using antler picks to scrape and gouge at the relatively soft limestone, and stone hammers to break through tougher sections, they slowly, painstakingly, carved out this underworld. The process would have been agonizingly slow. They had to create not only the large, open chambers, but also a complex system of passages, stairways, and windows connecting the different levels. The debris from this colossal excavation, an estimated 2,000 tons of rock, then had to be hauled up to the surface and removed, all through a single, small entrance. This was not a project of years, but of centuries, a sacred undertaking passed down through generations, with each one adding to and refining the work of their ancestors. Descending through its levels is like traveling deeper into the beliefs of its creators. The upper level, closest to the surface, is the oldest part, with a series of simple, rock-cut tombs that mimic the megalithic temples found above ground on Malta. As you move down to the middle level, the architecture becomes more sophisticated and awe-inspiring. Here, you find the most iconic chambers, carved to perfectly resemble the interiors of the above-ground temples, complete with corbelled ceilings that mimic the way those structures were roofed. There is the magnificent Holy of Holies, a chamber carved directly from the rock to look like the facade of a temple, with a trilithian entrance framing a doorway to a small, symbolic niche. The attention to detail is breathtaking. The builders were recreating their sacred architecture in negative space, carving out what was typically built up, creating a permanent, indestructible echo of their surface world in the heart of the earth. But of all the mysteries the hypogeum holds, the most captivating is its sound. This is a place of powerful, and likely intentional, acoustic phenomena. Certain chambers, particularly the so-called oracle room, possess remarkable sonic properties. A voice spoken in a specific low tone in this room resonates throughout the entire chamber, creating an immersive, vibrating effect that seems to come from the walls themselves. This is not a simple echo. It is a powerful amplification and reverberation that can be felt physically in the bones. Research has shown that the chamber resonates at a frequency that matches the natural resonant frequency of the human skull. The effect on someone standing in that space, in near total darkness, would have been profoundly disorienting and spiritually overwhelming. It would have seemed as if the stones themselves were speaking, as if the voice of a spirit or a god was emanating from the very earth. This leads to the profound question of the hypogeum's purpose, and here, the acoustic properties provide a vital clue. The complex served as a collective burial site. The remains of over 7,000 individuals were found within its chambers. But it was clearly far more than just a cemetery. The sophisticated architecture, the artistic decoration with red ochre spirals and patterns, and the powerful acoustics all point to it being a central sanctuary, a place of ritual and initiation. It is easy to imagine a shaman or priest standing in the oracle room, their voice transformed by the chamber into an otherworldly boom, delivering prophecies or communicating with the ancestors whose bones lay in the surrounding niches. The sonic effects could have been used to alter states of consciousness, to induce trances, and to create a powerful, multisensory experience that separated the initiated from the outside world. The hypogeum was a gateway, a physical and spiritual portal, connecting the world of the living with the realm of the dead. A place where through darkness, architecture, and sound, the Neolithic people of Malti believed they could touch the divine. Leaving behind the subterranean silence of Malta's hypogeum, we now travel to the heart of Southeast Asia, to the island of Java in Indonesia, where an entirely different kind of spiritual mountain rises from a lush, green plain. This is Borobudur, the world's largest Buddhist temple, a structure that is not so much a building as it is a three-dimensional map of the cosmos and a physical guide to enlightenment. Imagine a colossal, stepped pyramid, but one designed not for a pharaoh's ascent to the sun, but for a pilgrim's journey toward nirvana. Constructed in the 9th century during the Sailendra dynasty, Borobudur is a masterpiece of symbolic architecture, built from over 2 million blocks of gray andesite, a volcanic stone hauled from nearby riverbeds and quarries. What makes its construction so extraordinary is what's missing. There is no mortar holding this mountain together. Instead, every single one of those 2 million stones was meticulously shaped to fit with its neighbors using a complex system of interlocking grooves and knobs. A giant stone puzzle assembled with a precision that has allowed it to stand for over 1,200 years, resisting the relentless tropical rains and the tremors of a seismically active region. It is a testament to an engineering philosophy that prioritized harmony and balance over rigid adhesion. The temple's form is its deepest teaching. Borobudur is a massive stupa, designed as a representation of the Buddhist universe. Its structure is divided into 3 distinct tiers, mirroring the 3 realms of Buddhist cosmology. The massive, square base symbolizes the world of desire, Kamedhatu, where humans are bound by their passions. Above this rises the 5 concentric square terraces, representing the world of forms, Rupadhatu, where one is freed from desire but still bound to name and form. And crowning the entire monument are 3 circular platforms, dotted with 72 perforated stupas, leading to the great central stupa at the very summit. This represents the world of formlessness, Arupadhatu, the ultimate state of enlightenment and nirvana. A pilgrim's journey is a deliberate, clockwise ascent through these levels, a physical and spiritual circuit that takes them from the mundane world at the bottom to the transcendent realm at the top. This path is not a straight line, it is a ritual circumambulation covering a total distance of nearly 3 miles if one completes the entire route. The very act of walking this path is a form of meditation, a slow, deliberate unwinding of the self as one spirals upward towards liberation. The walls lining this sacred pathway are what transform Borobudur from an architectural marvel into an open-air library of stone. Carved into the balustrades of the 5 square terraces are nearly 1,500 exquisitely detailed narrative relief panels. If placed end to end, these panels would stretch for over 3 miles. They are not mere decoration, they are a sequential and comprehensive visual scripture, designed to instruct and guide the pilgrim on their path. The lowest levels depict the causes and effects of karma, showing scenes from the Jataka tales, the stories of the Buddha's previous lives, where he demonstrated virtues like generosity, patience, and morality. As you ascend, the narratives become more profound, illustrating the life of the historical Buddha, Prince Siddhartha, from his birth to his enlightenment, and finally, the panels on the higher terraces depict the more abstract teachings and the journeys of other enlightened beings, the bodhisattvas. The craftsmanship is breathtaking. Each panel is a dense, vibrant tableau filled with figures, palaces, landscapes, and celestial beings, all carved with such fluidity and grace that the stone seems to breathe. You can see the delicate fold of a robe, the serene expression on a face deep in meditation, the intricate architecture of a celestial pavilion, and the dynamic energy of a royal procession. These carvings were originally painted in vibrant colors and may have been adorned with gold leaf, making the entire monument a brilliantly polychrome vision of the Buddhist cosmos, a dazzling beacon of spiritual instruction. Creating this stone sculpture was a feat of both artistic vision and immense logistical planning. The andesite stone, while durable, is incredibly hard, requiring immense skill to carve with such fine detail. Artisans would have used a variety of iron chisels, hammers, and drills, slowly and patiently pecking away at the stone to first create the rough outlines before refining the incredible depth and detail we see today. The precision of the interlocking system, however, points to an even more sophisticated process. Each block was likely shaped and even partially carved at staging areas on the ground before being hoisted into its permanent position. The builders would have used earthen ramps that wrapped around the growing structure, similar to theories about the pyramids, allowing teams of workers to drag the heavy stones into place. The true genius lies in the joinery itself. The stones were cut with projecting knobs on their inner faces that fitted perfectly into corresponding slots on the adjacent stones. This created a flexible, interlocking wall that could shift and settle without collapsing, a crucial feature in a land of frequent earthquakes. This method required an unprecedented level of foresight. A single miscalculation in the shaping of one block could throw off the entire alignment of a terrace. The entire project, from quarrying to carving to final assembly, represents a harmonious collaboration between thousands of laborers, master stonemasons, and profound religious scholars, all working in concert to create a permanent guide to enlightenment, a sacred mountain that invites you not just to look, but to walk, to read, and to ascend. Returning to the heights of the Andes, we find ourselves standing before a fortress that seems less constructed by human hands and more like the work of mythical giants. Just a stone's throw from the ancient Inca capital of Cusco, Sacsayhuaman sprawls across a hillside, its most iconic feature being a series of 3 zigzagging defensive walls that ripple across the landscape. These are not ordinary walls. They are composed of colossal limestone blocks, some of which are truly titanic, exceeding 100 tons in weight and rising over 27 feet tall. To stand beside them is to feel a profound sense of your own scale in the world, dwarfed by stones that look as though they were placed by a god. The sheer mass is staggering, but it is the impossible precision of their joining that truly stops the heart. These are not uniform bricks. Each block is a unique, irregular polygon, a jigsaw puzzle piece of monumental proportions. shaped to fit perfectly with its neighbors on all sides. The seams between them are so exact, so flawlessly interlocked, that you cannot slip a razor blade, or even a single piece of paper, into the cracks. This is architecture as a perfect, three-dimensional mosaic, a testament to a stonemasonry technique so advanced it defies belief. The monumental task began not at the building site, but at the quarry. The primary source for these gargantuan stones was a location known as Waikoto, situated several miles away from Sacsayhuaman and, critically, at a lower elevation. This meant that every single multi-ton block had to be hauled uphill. Using stone hammers made of a harder material like dolerite, workers would first fracture the bedrock. They expertly carved channels and then used a combination of water, wood, and fire to expand cracks and split the stone, freeing these megaliths from the earth. Yet the quarrying was arguably the simplest part of the process. The true Herculean challenge was transport. Without the wheel, without draft animals stronger than the llama, which cannot carry heavy loads, the Inca relied entirely on human power, ingenuity, and a deep understanding of physics. The prevailing theory involves a system of log rollers, earthen ramps, and sheer manpower. Teams of hundreds, perhaps thousands, of laborers would have used thick, braided ropes made from leather and natural fibers to pull the stones on wooden sledges. They likely constructed temporary roadways and used levers to navigate the stones over rough terrain, inching them slowly and deliberately up the mountain in a coordinated effort that must have been one of the most grueling logistical operations in the ancient world. Once these behemoths arrived at the site, the most perplexing phase began, the shaping. How do you transform a rough, 100-ton block of stone into a perfectly fitting puzzle piece? The Inca had no iron tools, no laser-guided cutters. Their toolkit consisted of harder stone hammers, bronze chisels, and simple abrasives like sand and water. The process was one of relentless patience and profound skill. Stonemasons would have used the stone hammers to pound the stone into a general shape, a technique where they would repeatedly strike the surface to fracture small pieces away, slowly approaching the desired form. But the final hair's-breadth precision was achieved through a method of trial and error that is almost unimaginable. A block would be roughly positioned next to its neighbor. The masons would then identify the high spots and, using a harder stone or an abrasive paste, grind down the protruding areas. They might have used a technique of rubbing a colored substance on one stone and then pressing it against its neighbor. The colored marks transferred would indicate exactly which points needed to be painstakingly ground down next. This iterative process of fitting, marking, and grinding would be repeated over and over until the two surfaces matched with that legendary, airtight perfection. The result of this mind-boggling effort is a wall that is not only visually imposing, but also structurally magnificent. The irregular, interlocking design is far more than an aesthetic choice. It is brilliant earthquake engineering. Peru sits on one of the most seismically active zones on the planet. A wall made of uniform, rectangular blocks with straight mortar joints would be rigid. When a powerful tremor hits, such a wall would crack and crumble as the ground shakes beneath it, but the polygonal walls of Sacsayhuaman are naturally flexible. When an earthquake strikes, the jigsaw-like stones are designed to shift, to sway, and to dance within their tightly locked embrace. They absorb and dissipate the energy of the tremor, and when the shaking stops, they settle perfectly back into place. This is architecture that anticipates movement, that understands dynamic forces in a way that feels incredibly modern. The walls were so effective that the Spanish conquistadors, who later plundered the site for stone to build their own colonial city in Cusco, believed they had to have been the work of demons, as human effort alone seemed an insufficient explanation for such resilient perfection. Beyond its physical and engineering marvels, Sacsayhuaman's purpose remains a subject of intriguing debate. Its name is often translated as Satisfied Falcon, and its traditional classification is that of a fortress. The three-tiered, zigzagging walls create deadly kill zones, and its commanding position overlooking Cusco made it a formidable defensive stronghold, a role it famously played during the Inca Rebellion of 1536. However, many researchers now believe its function was far more complex. The sheer artistic effort invested in the stonework, the precise astronomical alignments found within the complex, and its connection to the sacred landscape suggest it was also a major ceremonial center. Some of the largest stones are positioned to align with the solstices, and the entire complex may have been designed to represent the head of the puma, whose body was mapped out by the city plan of Cusco itself. Sacsayhuaman, therefore, stands as a multifaceted symbol of the Inca Empire, a demonstration of military might, a temple to celestial forces, and an enduring monument to a stonemasonry tradition that turned brute stone into a living, breathing, and indestructible part of the Andean Mountains. Standing guard on the Giza Plateau, its immense lion's body resting in the sands and its human gaze fixed eternally on the eastern horizon, the Great Sphinx presents a riddle wrapped in stone and mystery. Unlike the assembled pyramids nearby, this is not a structure built block by block, but one revealed, a colossal sculpture carved directly from the living bedrock of the Makatim Formation. Imagine a single, natural outcrop of limestone, a stubborn hillock left behind in the quarry that supplied stone for the Great Pyramid. To the ancient Egyptians, this was not an obstacle, it was an opportunity. They saw the potential for a guardian deity within that rock, and with relentless vision, they set about liberating it, sculpting a figure that stretches 240 feet in length and towers 66 feet high. This subtractive process was one of supreme confidence, a point of no return where every strike of a tool permanently removed stone. There were no second chances, no way to reassemble a mistakenly carved feature. The very existence of the Sphinx is a testament to the unshakable skill and planning of its creators. The methods used for this epic act of carving were, in principle, straightforward, yet their execution on such a scale is staggering. The primary tools were copper chisels and stone hammers. Copper, a relatively soft metal, would have been workable for carving the limestone but would dull quickly, requiring constant resharpening and replacement by teams of workers supporting the master carvers. The process likely began with teams of laborers removing the vast bulk of unwanted stone around the future body of the Sphinx, creating the deep, horseshoe-shaped quarry that surrounds it. As the general form of the recumbent lion emerged from the bedrock, the sculptors would have moved in. Using stone balls, some weighing as much as 50 pounds, workers would have pounded the surface to rough out the shape. Then, with copper chisels and wooden mallets, the fine details would be carved: the powerful legs, the coiled tail, and most importantly, the serene, enigmatic face believed to be a likeness of the pharaoh Khafre. Water was likely used to soften the stone and reduce dust, with workers possibly tracing guidelines on the wet surface to guide their work. The final step would have been to polish the entire sculpture with abrasives like quartz sand, giving it a smooth finish that would have gleamed brilliantly under the Egyptian sun before being painted in vivid colors, traces of which can still be seen by one of its ears. This traditional narrative, which places the Sphinx's construction during the reign of Khafre around 2500 B.C., is compelling and fits neatly with the timeline of the Giza Pyramid complex. However, a fascinating and persistent challenge to this dating has emerged from a close examination of the statue's body, focusing on the very clear and distinctive pattern of erosion etched into its limestone flanks. While the head and upper body show weathering consistent with wind and sand, the core of the Sphinx and the walls of its enclosure exhibit deep, undulating, vertical fissures, and what appear to be classic examples of water erosion. This type of severe, rolling erosion is characteristic of prolonged and heavy rainfall, where water cascades over a surface in sheets, carving out deep channels and creating a distinctly rounded, cavernous appearance. This presents a profound geological puzzle, because the climate of Egypt for the last 5,000 years has been overwhelmingly arid, a hyper-dry desert where wind and sand are the primary erosive forces, not rain. This observation forms the core of the controversial water erosion hypothesis, which suggests the Sphinx is far older than the 4th dynasty, potentially dating back to a time when the Sahara was a verdant savanna that received significant rainfall. This would push its origin back to perhaps 7,000 or even 9,000 years ago, a time before the dawn of dynastic Egypt. Proponents of this theory argue that the sheer depth and nature of the erosion patterns required millennia of exposure to torrential rains to form, a climatic condition that last existed in the region around the end of the last ice age. They point to the fact that the erosion is most severe on the upper walls of the Sphinx enclosure and less so at the bottom, a profile that matches water runoff, not wind-borne sand, which typically scours the base of structures more aggressively. This theory, if correct, would fundamentally rewrite our understanding of early civilization, suggesting a sophisticated, monumental building culture existed long before the pharaohs we know. Mainstream Egyptology offers compelling counter-arguments to this radical redating. Geologists who support the traditional timeline point out that the limestone of the Giza Plateau is not a uniform block. It is composed of different layers with varying densities and compositions. The core body of the Sphinx is carved from a softer, more porous layer that is inherently more vulnerable to all forms of weathering. They argue that what appears to be water erosion could easily be the result of other processes. One major factor is the phenomenon of haloclasty, where salts crystallize within the stone. Groundwater, which can rise and fall in the plateau, carries dissolved salts. As this moisture evaporates from the surface of the limestone, the salts crystallize and expand, forcibly prying the stone apart from within, creating exfoliation and deep fissures that can mimic water channels. Furthermore, the intense diurnal temperature swings in the desert cause the stone to expand and contract daily, leading to cracking and spalling over centuries. When you combine this chemical and thermal stress with the relentless, sand-blasting effect of wind over 4,500 years, the unique erosion patterns on the Sphinx begin to look less like a definitive signature of rainfall and more like the complex result of multiple, ongoing natural processes acting on a vulnerable and heterogeneous rock formation. The debate is further complicated by the Sphinx's own restoration history, which adds another layer of complexity to reading its weathered skin. For millennia, the statue has been periodically buried and excavated from the encroaching desert sands. Since at least the time of the New Kingdom pharaoh Thutmose IV, over 1,000 years after its traditional construction date, efforts have been made to restore and protect it. The most visible testament to this is the extensive masonry cladding that covers its lower body and paws. This is not the original stone, but repair work from different eras, with blocks dating from ancient Egyptian times to the Roman period and modern restorations. This continuous cycle of burial, exposure, and repair has undoubtedly altered the statue's surface and complicates any simple geological analysis. The parts of the Sphinx we see today are a palimpsest, a layered document where ancient erosion, ancient repairs, and modern conservation are all intertwined, making it incredibly difficult to isolate a single, clear story of its wear and tear. The mystery of the Sphinx, therefore, endures not merely as a question of who built it, but as a deeper puzzle about how we interpret the slow, patient language of time itself, written in the weathered stone of a timeless monument. Our journey now takes us back even further in time, to the banks of the mighty Indus River around 2600 B.C., to a city that represents one of history's greatest and most mysterious urban experiments, Mohenjo-Daro. In the heart of this meticulously planned metropolis, amidst a grid of standardized brick houses and wide, straight streets, lies a structure that speaks volumes about the people who built it, the Great Bath. This is not a colossal pyramid or a towering temple, but a large, watertight pool, and its sophisticated engineering reveals a civilization obsessed with order, cleanliness, and perhaps ritual purity. Imagine a vast, rectangular tank, sunk into the ground and measuring approximately 39 feet long, 23 feet wide, and 8 feet deep. What makes it extraordinary is not its size, but its incredible construction, a feat of hydraulic engineering that would not be rivaled for millennia. The entire bath is built with 2 layers of finely baked, standardized bricks, laid carefully with a binding material of gypsum plaster. But the true secret to its longevity lies in what was placed between these layers, a thick, carefully applied coating of natural bitumen, a tar-like substance that acted as a powerful waterproofing agent. This ensured that the precious water held within the bath did not simply seep away into the thirsty ground, creating a permanent, reliable reservoir in the center of the city. The brilliance of the Great Bath extends far beyond its waterproofed walls. The entire complex was part of an integrated water management system of astonishing foresight. Surrounding the central tank are rows of small, private rooms and a large, colonnaded courtyard, suggesting this was more than just a public swimming pool. It was likely a central feature of a larger ritual or social complex. The true engineering marvel, however, lies in its plumbing. The bath was equipped with a sophisticated drainage system to allow for regular cleaning and water changes. At one corner of the tank, a well-designed outlet was constructed, leading to a large corbelled drain made of baked bricks. This drain was so wide that a person could actually walk through it for maintenance, a remarkable feature that underscores the importance the Indus Valley people placed on functionality and hygiene. They even designed a system to carefully control the flow, ensuring the bath could be emptied and refilled efficiently. This attention to hydraulic detail is a hallmark of the entire city, with nearly every house in Mohenjo-Daro containing its own bathing area and wastewater drains that connected to covered, centralized sewers running beneath the main streets, a level of urban sanitation that would not become standard in Europe until the Roman era, over 2,000 years later. This single structure, the Great Bath, cannot be fully understood in isolation. It is the glittering centerpiece of a much larger philosophy of urban design that makes the Indus Valley civilization so unique and enigmatic. Unlike the monumental, god-king-focused architecture of Egypt or Mesopotamia, the grandeur of Mohenjo-Daro is found in its breathtaking rationality. The entire city was built on a deliberate grid plan, with main streets running north-south and east-west, dividing the city into large, functional blocks. This required a phenomenal degree of central planning and social organization. Even more astonishing is the evidence of standardization that runs through every brick and every street. The baked bricks used throughout Mohenjo-Daro, and indeed across the far-flung cities of the Indus Valley, were produced in a consistent, standardized ratio. Their dimensions were uniformly balanced, with a common ratio of length to width to thickness of 4:2:1. This meant that bricks from one part of the city would fit perfectly with bricks from another, allowing for efficient, modular construction and repair. This implies the existence of a central authority with the power to enforce such uniformity, not for a single royal project, but for an entire, sprawling urban center. The purpose of the Great Bath, while not explicitly recorded, is deeply intertwined with this culture of order and advanced urban life. The prevailing theory among archaeologists is that it served a primarily ritual or religious function. In a society that clearly placed a high value on water management and personal cleanliness, a large, centrally located, and meticulously maintained pool would have been the perfect venue for communal bathing ceremonies, possibly related to spiritual purification. The surrounding rooms may have been used for changing, preparation, or even as dwellings for a priestly class who oversaw the rituals. The sheer quality of its construction, far superior to that of a mere public utility, supports this idea. It was a sacred civic space, a place where the community's relationship with water, a vital and sometimes destructive force in a river valley, was formalized and celebrated. The Great Bath of Mohenjo-Daro, therefore, stands as a powerful symbol of a lost world. It represents a civilization that achieved a remarkable balance between the practical and the spiritual, between engineered efficiency and communal ritual, creating a legacy of urban genius that remains quietly impressive, even when compared to the more flamboyant megastructures of the ancient world. But after the visual spectacle of colossal pyramids and intricate temples, sometimes the most profound statements are made through elegant simplicity. Tucked away in the plain of Pasargadae, in what is now modern-day Iran, stands a monument that speaks not of overwhelming power, but of a different kind of majesty, the tomb of Cyrus the Great. In a world of architectural giants, this structure is remarkably modest in scale, a simple stone house resting on a stepped platform, yet its historical and engineering significance is immense. It was built around 530 B.C., as the final resting place for Cyrus, the founder of the vast Achaemenid Empire, a ruler revered for his unprecedented policy of tolerance towards the many cultures and religions he conquered. The tomb reflects this philosophy. It lacks the intimidating grandeur of other royal tombs. Instead, It projects a sense of dignified restraint, a quiet confidence that needs no embellishment. It is a monument to a man, not just a king, and its enduring survival is a testament to the respect he commanded, even from his enemies, and the brilliance of its unadorned construction. The construction of the tomb is a masterclass in precision and foresight. The entire structure is composed of massive, finely dressed limestone blocks, cut and finished with such care that they fit together with barely a visible seam. The platform consists of 6 receding tiers, creating a solid, stable base that lifts the tomb chamber above the plain. The chamber itself is a small, rectangular room, but its most astonishing feature is the roof. Unlike a structure built with many smaller stones vaulted or corbelled together, the roof of Cyrus's tomb is a single, enormous gable slab. That's right, each sloping side of the roof is made from one solid piece of limestone, quarried, shaped, and then lifted into place to form a perfect, peaked roof. The weight of these single slab roof pieces is staggering, each one estimated to weigh between 35 and 40 tons. The logistical feat of moving these monoliths and then positioning them with such accuracy, using only ramps, ropes, levers, and human labor, demonstrates a level of engineering skill that is as impressive in its own way as the construction of a much larger pyramid. This seemingly simple design is the secret to the tomb's incredible longevity. For 2,500 years, this region has been prone to significant and devastating earthquakes, forces that have toppled far more robust-looking structures. Yet the tomb of Cyrus has stood firm, a solitary sentinel against the relentless tremors of time. Its resilience lies in the brilliant combination of its precise joinery and its unique foundation system. The limestone blocks were cut so perfectly that they fit together almost like a dry stone wall, but on a monumental and exact scale. This tight fit creates a structure that acts as a single, cohesive unit. When an earthquake strikes, the entire tomb is designed to sway and move as one piece, rather than having individual components shake and grind against each other, which would quickly lead to collapse. The joints are so tight that there is very little room for destructive movement. Furthermore, the foundation itself is a work of genius. The massive stone blocks of the platform were set not on a flat, rigid surface, but on a specially prepared bed of stone and gravel. This acts as a kind of primitive but highly effective shock absorber. When seismic energy travels up from the ground, this flexible base allows the entire structure to shift and rock slightly, dissipating the destructive force of the earthquake before it can concentrate and crack the perfectly fitted stones above. It's a concept that modern earthquake engineers understand well: isolation from the ground's motion. The ancient builders of Pasargadae intuitively understood this principle, creating a foundation that allowed their king's tomb to dance with the earth rather than fight it. The result is a building that has outlasted empires, a quiet, enduring tribute to both the man it honors and the anonymous builders whose simple, brilliant solutions have proven stronger than the forces of nature itself. Now, let's shift our focus from the intricate carvings of Java and the colossal walls of the Andes to one of the most expansive and enigmatic prehistoric sites in all of Europe. Imagine a landscape not dominated by a single, towering structure, but transformed by thousands of them, standing in silent, orderly rows that stretch for miles across the countryside of Brittany, France. This is the site of the Karnak stones, a breathtaking megalithic complex consisting of over 3,000 granite standing stones, or menhirs, arranged in long, parallel alignments. Unlike a pyramid or a temple, this is a monument of pure geometry and scale, a project that seems to have transformed the very fabric of the land itself. The sheer number of stones is the first thing that overwhelms the senses. To walk among these alignments, such as the famous Manek Rose with its 11 converging lines of 1,165 stones, is to feel you are navigating a grid built for giants, a vast, open-air cathedral without a roof, where the pillars are these ancient, weathered sentinels of stone. The effort to create this is almost beyond comprehension, a communal undertaking that must have consumed generations. The physical challenge began at the source, as the builders had to first extract these massive granite blocks from the local bedrock. Using a combination of fire and water, they would heat the stone with fire and then rapidly cool it with water. causing it to fracture along natural fault lines. Then, with stone mauls and antler picks, they would laboriously work the stone free. But extracting the menhir was only the beginning. Transporting these multi-ton slabs of granite, some weighing as much as 50 tons, across the rolling Breton landscape was a logistical nightmare. Without the wheel or draft animals, the primary tools were once again human muscle, simple physics, and immense patience. The most likely method involved a combination of wooden sledges, log rollers, and a carefully prepared trackway. Teams of workers would have hauled on ropes made from plant fibers or animal hide, inching the massive stones along their path. To maneuver a stone onto its sledge or to make a turn, they would have used massive wooden levers, lifting one side at a time to adjust its course. The final act of raising the stone was a delicate and dangerous ballet of coordination. A large pit would be dug, and the stone would be dragged to its edge. Using levers and a system of ropes, the community would slowly pull the stone upright, while others packed the base with smaller stones and earth to secure it in its permanent, vertical stance. This process, repeated thousands of times over centuries, represents one of the most sustained and coordinated building projects in human prehistory. With such a staggering investment of labor and time, the inevitable question is, why? What compelled the people of Neolithic Brittany to rearrange their entire landscape in this way? The theories are as numerous and intriguing as the stones themselves, and no single explanation has yet claimed victory. One of the most enduring ideas is that the alignments functioned as a sophisticated astronomical observatory. Some researchers have noted that the lines appear to be aligned with the rising and setting sun at the solstices and equinoxes. The possibility exists that the carefully arranged rows acted as a giant calendar, marking the passage of the seasons for a society deeply dependent on agriculture. By observing the sun's movement against the fixed grid of stones, Neolithic priests or astronomers could have predicted the optimal times for planting and harvest, and coordinated the rituals that ensured the community's survival. This theory transforms the site from a random collection of stones into a complex scientific instrument, a stone computer for calculating celestial time. A competing, and perhaps more spiritually resonant, theory posits that the alignments were part of a vast sacred landscape dedicated to religious worship and ancestor veneration. In this view, the long, parallel rows served as processional avenues, guiding participants through a ritual landscape toward a sacred destination, perhaps a burial mound or a timber-circled temple that has long since vanished. The stones themselves, often sourced from distinctive locations, may have been seen as vessels for spiritual energy or as representations of ancestral figures. The very act of erecting them could have been a ritual in itself, a way for the community to cement its relationship with the land and the supernatural forces that governed their world. This interpretation suggests that Karnak was not a place for cold calculation, but for powerful, communal spiritual experiences, where the physical journey through the stones was a metaphor for a spiritual passage. Yet another fascinating line of thought moves away from the celestial and the sacred toward the deeply practical and social. Some archaeologists propose that the primary function of the Karnak alignments was to demarcate territory, serving as a highly visible and permanent statement of a tribal identity and land ownership. In a time when societies were becoming more complex and competing for resources, such a colossal project would have been a powerful display of a community's unity, strength, and organizational ability. It was a message carved into the land itself, declaring, "We are here, we are powerful, and this land is ours." The sheer scale of the project would have required cooperation across a wide area, potentially fostering social cohesion and establishing a collective identity that transcended individual villages. The stones, in this light, are not just astronomical tools or religious icons. They are the political and social bedrock of a civilization asserting itself upon the world. The true purpose of the Karnak stones likely lies in a combination of all these ideas, a place where science, spirituality, and society converged, creating a monument so vast that its full meaning continues to elude us, standing in silent rows as they have for over 6,000 years. But after exploring the sun-scorched plains, wind-swept mountains, and sprawling stone complexes of the ancient world, we must now descend, leaving the light behind to uncover a marvel of a different kind, a city built not to reach for the heavens, but to retreat from the world above. Deep within the heart of Cappadocia, in central Turkey, lies the Derinkuyu underground city, a labyrinthine metropolis carved entirely downward into the region's soft, malleable volcanic rock, known as tuff. This was not a single shelter or a simple cave complex. It was a fully functional, multi-level city capable of housing up to 20,000 people along with their livestock and supplies, a breathtaking feat of subterranean engineering designed for long-term survival. The scale is almost incomprehensible. While 18 levels have been discovered, only 8 are accessible to the public, descending to a depth of nearly 280 feet. Walking through its narrow, sloping passages is like entering another world, a silent, stone honeycomb that reveals a civilization's determination to endure against any threat. The very rock of Cappadocia made this ambitious project possible. Millions of years ago, volcanic eruptions blanketed the area with a thick layer of ash, which compressed into a soft, easily workable tuff. This material was the perfect medium for ambitious builders armed with little more than determination and simple hand tools. Using picks, shovels, and baskets made from animal hide, generations of people, beginning possibly with the Phrygians in the 8th to 7th centuries B.C., and later expanded by early Christians, began the monumental task of excavation. They didn't build this city, they sculpted it through removal, hollowing out the earth room by room, passage by passage. The process was one of incredible patience and foresight. Workers had to carefully calculate the structural integrity of the rock, leaving behind robust pillars and arches to support the immense weight overhead, ensuring that ceilings would not collapse under the pressure of the world above. The entire city is a negative space, a complex void carved with purpose and precision, a testament to a deep, intuitive understanding of their geological environment. Creating a livable environment for thousands of people, so far beneath the surface, presented a series of profound engineering challenges, the solutions to which are nothing short of brilliant. The most immediate need was, of course, breathable air. The builders addressed this with over 50 expertly carved ventilation shafts. These narrow wells, some reaching all the way to the surface, acted as the city's lungs, creating a natural convection current that constantly circulated fresh air throughout every level, from the deepest storerooms to the highest living quarters. Without this sophisticated system, the city would have become a suffocating tomb in a matter of hours. The second critical challenge was water. Derinkuyu features massive, deep wells that tapped into the same underground water table that supplied the surface world. These secure internal water sources meant that inhabitants could withstand a prolonged siege without ever needing to venture outside, making the city a virtually impregnable fortress. The water wells were also strategically designed with narrow, defensible mouths to prevent contamination from above. Moving through the city reveals a layout of astonishing complexity and clever design. The entrance points were deliberately inconspicuous and easily defensible, often hidden within surface-level courtyards of ordinary-looking homes. Once inside, a visitor would navigate a warren of low-ceilinged, sloping corridors. These passages were not built for comfort, but for security. Many are so narrow that only one person can pass through at a time, and they are intersected by enormous, rolling stone doors. These circular portals, weighing up to half a ton, could be rolled across key passageways from the inside, effectively sealing off entire sections of the city from invaders. They functioned like the blast doors of a modern bunker, and their presence at every major junction shows that security was woven into the very fabric of Derinkuyu's design. Beyond the defensive corridors lay a complete urban ecosystem. There were spacious family dwellings, complete with carved-out beds, shelves, and communal living areas. There were kitchens with blackened ceilings from cooking fires, the smoke of which was cleverly channeled through tiny, disguised vents to avoid detection from the surface. There were stables for livestock, cellars for storing massive quantities of food and wine, and even dedicated areas for pressing grapes and producing oil. The social and spiritual life of the community was also provided for deep within the earth. Among the most remarkable spaces in Derinkuyu is a large, cruciform church, a single nave structure with a high, vaulted ceiling and an altar, all carved directly from the living rock. This was not a hastily made chapel, but a proper place of worship, indicating that religious observance was a central part of life, even during times of refuge. The presence of such a dedicated space, along with baptismal fonts and missionary schools found on other levels, speaks to a highly organized society that valued its cultural and spiritual identity. This leads to the fundamental question of why such an immense underground refuge was necessary. Historians believe Derinkuyu and the other underground cities in the region served as a perfect defensive haven during periods of intense persecution and invasion. For the early Christian communities of the Byzantine era, it was a sanctuary from Roman raids and later from Arab incursions. The city provided a safe haven where entire communities could disappear from sight for months at a time, preserving their way of life against existential threats. Derinkuyu stands as a powerful monument not to conquest or divine glory, but to sheer resilience, a stunning collective achievement born from the universal human need for security, community, and the enduring will to survive against overwhelming odds. From the hidden depths of Derinkuyu, we emerge into the light and travel to a place where faith was carved on a truly monumental scale, not to hide from the world, but to watch over it. In China's Sichuan province, at the sacred confluence of the Minjiang, Dadu, and Qingyi rivers, a colossal serene figure sits in perpetual contemplation. This is the Leshan giant Buddha, the largest stone Buddha statue in the world, a 71-meter-tall titan carved directly into the face of a crimson sandstone cliff. To stand at its feet is to be utterly dwarfed. Its shoulders are 28 meters wide, its smallest toenail is large enough to seat a person, and its ears are over 7 meters long. The statue is so immense that it is famously said, "The mountain is a Buddha, and the Buddha is a mountain." But this is more than a record-breaking sculpture. It is a testament to a single man's profound devotion and an entire community's 90-year commitment to a seemingly impossible dream. The story of the Buddha's creation begins not with an architect or an emperor, but with a humble Buddhist monk named Hai Tong. During the Tang dynasty in the early 8th century, Hai Tong was deeply troubled by the treacherous waters where the three rivers met. The violent currents created powerful whirlpools that routinely capsized fishing boats and took countless lives. He believed a malevolent water spirit was responsible, and he conceived of a radical solution. He would carve a colossal image of Maitreya, the future Buddha, into the cliff face. His vision was that the serene, powerful presence of the Buddha would calm the water spirit and pacify the turbulent rivers, providing safe passage for all. Hai Tong spent years traveling and tirelessly collecting alms to fund his monumental project. According to legend, when local officials tried to extort the funds he had raised, the monk famously declared, "You can pluck out my eyes, but you cannot take the money for the Buddha." In a dramatic act of defiance and faith, he is said to have gouged out his own eyes and presented them to the corrupt magistrates, an act that shamed them into leaving the project alone. While the historical accuracy of this tale is debated, it powerfully illustrates the depth of Hai Tong's determination, a determination that would outlive him and fuel a project spanning 3 generations. The construction itself, which began in the year 713 A.D., was an engineering nightmare that played out on a vertiginous cliff face. Unlike the top-down approach used at Petra, the workers at Leshan had to orchestrate their efforts from both the top and the bottom simultaneously. There was no scaffolding that could reach such heights. Instead, workers were suspended by ropes from the top of the cliff, dangling precariously over the swirling river below. Their tools were brutally simple: iron chisels, hammers, and picks. The primary method was one of sheer, patient subtraction. Teams of workers would carve deep channels and holes into the cliff to isolate large sections of rock, and then, using wedges and levers, they would fracture and pry these sections loose, sending them tumbling into the river below. This process was incredibly dangerous, and the river slowly began to fill with the rubble of the mountain itself. In fact, an unintended but welcome consequence of this method was that the immense amount of stone dumped into the river actually altered its flow, taming the very whirlpools that Hai Tong had sought to calm, and making the waterways safer even before the statue was completed. It was a project of faith that yielded practical results from the very beginning. Perhaps the most ingenious aspect of the entire endeavor is invisible to the casual observer. The Lushan giant Buddha is not a solid, impermeable sculpture. It is a brilliantly engineered structure designed to survive the elements. The humid, rainy climate of Sichuan posed a grave threat to the soft sandstone, as water seepage and freeze-thaw cycles could have cracked and eroded the statue to ruin within centuries. The master builders, carrying the project forward after Hai Tong's death, integrated a sophisticated internal drainage system directly into the statue's anatomy. A network of hidden gutters and water channels was carved behind the head, within the hair curls, and down the back of the robe. These discrete passages cleverly divert rainwater away from the main body, channeling it through the statue and out through drainage holes in various locations, preventing water from pooling and causing damage. This system has functioned flawlessly for over 1,200 years, a key reason why the statue has retained its magnificent form. Additionally, the builders even included a unique preservation feature within the coiled bun of hair on the Buddha's head, a subtle, camouflaged door that leads to a small chamber, likely used for inspection and maintenance. The project was a marathon, not a sprint, finally reaching completion 90 years after it began, in the year 803 A.D. Hai Tong never lived to see his vision realized, but his disciples and later generations of craftsmen carried the sacred work forward, their collective effort culminating in one of the most awe-inspiring acts of religious devotion in human history. The statue was originally protected by a massive, 13-story wooden pavilion that shielded it from the rain, but this structure was destroyed by Mongol invaders during the wars at the end of the Yuan dynasty. Remarkably, exposed to the open air, the Buddha's sophisticated drainage system proved its worth, allowing it to endure where a lesser creation would have crumbled. Today, the Lushan giant Buddha continues its eternal vigil, a serene giant born from one monk's faith and the tireless work of thousands of anonymous hands. It stands as a powerful fusion of spiritual aspiration, artistic genius, and practical engineering, a monument that truly did calm the waters, both of the river and of the human spirit. Now let's journey deep into the jungles of Guatemala, where the ancient Mayan city of Tikal pierces the emerald canopy. Here, in this sprawling metropolis, the Maya didn't simply build pyramids. They engineered sacred mountains aimed at propelling their rulers and priests closer to the gods. The most iconic of these, Temple Roman IV, soars to a height of over 230 feet, making it one of the tallest pre-Columbian structures in the entire Americas. To stand at its base and look up is a dizzying experience. Its steep stone staircase climbs impossibly toward the sky, culminating in a magnificent, towering roof comb, a stone latticework facade that would have originally been painted in vibrant colors, making the temple visible for miles across the flat jungle landscape. These temples were far more than just religious sites. They were the very axis mundi of the Mayan world, physical conduits connecting the earthly realm with the celestial heavens, and their construction was a logistical triumph that transformed the local landscape itself. The primary building block of Tikal was the abundant limestone that lay beneath the jungle floor. The Maya were masters of their environment, establishing an extensive network of quarries right within and around their city. Using harder stone tools, such as dolerite hammers and obsidian chisels, workers would first carve deep trenches around a block of limestone. Then, they would employ a clever technique using fire and water. They would heat the stone with fire and then rapidly cool it by dousing it with water, causing the rock to fracture cleanly along the desired line. Once a block was freed, it was shaped and smoothed before beginning its journey to the construction site. But moving these multi-ton blocks through dense jungle and across uneven ground required more than just manpower. It required infrastructure. The Maya engineered a complex system of raised causeways, known as sakbiab, which acted as the city's highways. These wide, paved roads, built of packed earth and limestone plaster, provided firm, level pathways. Teams of laborers would then drag the massive stones on wooden sledges or roll them on logs along these causeways, efficiently transporting the very bones of their city from quarry to temple. Once the stone arrived at the site, the challenge shifted from transport to elevation. How do you lift stones weighing several tons to the top of a 200-foot pyramid? The Maya, like the Egyptians, relied on the simple but profoundly effective principle of the earthen ramp. As the pyramid grew in height, the builders constructed a massive ramp of compacted earth, rubble, and limestone debris against its side. This ramp would spiral or run straight up the growing structure, providing a continuous, manageable slope for workers to haul the stones upward. It was a slow, grueling process, powered by human strength and coordinated by rhythmic commands. To maneuver the stones into their precise positions, they used wooden levers, ropes made from henequen plant fibers, and rollers. The entire pyramid was essentially encased in this temporary earthen shell during construction, a sight that would have been just as colossal as the finished temple itself. Once the final stone was set and the last decorative element was in place, the ramp was carefully dismantled, layer by layer, revealing the finished, majestic temple in all its glory for the first time. The architectural ingenuity of the Maya is perhaps best showcased not in the pyramid's massive bulk, but in their interior spaces, specifically through their unique solution for spanning openings, the corbel arch. Unlike the true, load-bearing Roman arch that uses a keystone to distribute weight outward, the Mayan corbel arch is a false arch, built through a technique of progressive stepping. To create a doorway or a vaulted chamber, masons would lay each successive course of stone blocks so that it projected slightly inward over the one below. This creates a characteristic inverted V-shape, where the two sides of the arch meet at the top without a keystone. The stability comes from the weight of the masonry above pressing down, locking each stepping stone firmly in place. While not as strong or as spacious as a true arch, the corbel vault was perfectly suited for the Mayans' needs, allowing them to create long, narrow passageways and interior rooms within their temple pyramids. This technique is a hallmark of classic Mayan architecture, a distinctive signature that required immense precision, as any miscalculation in the angle of the inward projection could lead to a catastrophic collapse. The final breathtaking element of these temples was the roof comb, that towering, ornate crest that crowned the summit. These were not merely decorative flourishes. They were massive, heavy structures in their own right, built from stone and masonry, and often filled with rubble for stability. Erecting these combs at such a great height was the culmination of the entire construction process. It is believed that the builders used the same earthen ramps that served for the pyramid's construction, extending them right up to the temple summit. The individual components of the roof comb large stone panels, elaborate sculptural elements, and the rubble core would have been dragged up this final, soaring incline. Once in place, these combs were adorned with stucco and painted with vivid scenes depicting the temple's patron ruler interacting with gods and ancestors, their images silhouetted against the sky. This transformed the temple into a colossal billboard of royal and divine power, a beacon of Mayan civilization that announced the authority of its kings to every corner of the city and the jungle beyond. The temple at Tikal was thus a complete engineering package, from the quarries that supplied its bones, to the causeways that connected them, to the ramps that raised them, and the brilliant corbel arches and roof combs that defined its majestic silhouette against the Central American sky. Returning now to the sun-drenched island of Malta, we encounter a pair of structures that bring our journey full circle, back to the mysterious temple builders whose underground sanctuary, the hypogeum, we explored earlier. Rising from a dramatic, wind-swept headland overlooking the Mediterranean Sea, the Hagar Kim and Mnajdra temple complexes stand as weathered, above-ground counterparts to that subterranean world. These are not crude arrangements of boulders, but sophisticated architectural ensembles composed of massive, shaped stone slabs, some weighing close to 20 tons, arranged into a series of elliptical chambers and ceremonial spaces. The scale is humbling, but the true marvel lies in the details. The careful corbelling of walls that once supported domed roofs, the intricately carved spiral motifs on altar stones, and the presence of features so specific and strange they seem to whisper of rituals long forgotten. These temples, built between 3600 and 3200 B.C., represent the pinnacle of the temple period, a final, magnificent flowering of megalithic genius before the civilization that created them vanished into the mists of prehistory. The very material used in their construction presents an intriguing paradox. The temples were built primarily from Globigerina limestone, a stone that is surprisingly soft and malleable when first quarried, almost like a hard cheese. This characteristic made it infinitely easier to shape and carve with the simple stone, wood, and antler tools available to the builders. They could cut it, smooth it, and incise it with a level of precision that would have been impossible with harder, more intractable rock. Yet this same softness should, in theory, have made the temples vulnerable to the relentless erosion of sun, wind, and salt spray over more than 5,000 years. The fact that they still stand, with their carvings and architectural features remarkably intact, is a testament to a fascinating natural process. Once exposed to the air, Globigerina limestone undergoes a kind of self-preservation. It develops a hard, protective crust, a patina formed by the reaction of the calcium carbonate in the stone with rainwater and carbon dioxide in the atmosphere. This outer shell, like a coat of armor, has shielded the softer interior stone from the elements, allowing these delicate masterpieces to endure for millennia, far longer than anyone could have predicted. Walking through the entrance of Hagar Kim, you are immediately struck by the sheer mass of the stones used in its facade. The central doorway is a monumental trilithon, two upright slabs supporting a massive horizontal lintel, a design that would echo through the ages in places like Stonehenge. But it is inside, amidst the labyrinth of chambers, that one finds the most enigmatic features, the so-called oracle holes. These are carefully carved, elliptical apertures piercing the thick stone walls that separate the inner chambers from the outer areas. Their purpose remains one of the great puzzles of Maltese archaeology. One prevailing theory is that they served an acoustic and theatrical function in rituals. A priest or shaman could have hidden in the outer space, speaking or chanting through the hole. To those gathered in the inner sanctuary, the voice would seem to emanate magically from the stone wall itself, a disembodied oracle delivering messages from the spirit world. This would have been a powerful tool for a spiritual leader, creating an awe-inspiring experience that reinforced their connection to the divine. Alternatively, these holes might have been used for making offerings, passing ritual objects from one sacred space to another, or even for astronomical observations, with a beam of light penetrating the darkness on a significant day. While the oracle holes suggest an intimate, internal ritual experience, the nearby Mnajdra temple complex reveals a grand, cosmic ambition. This lower temple is one of the world's oldest known and most precise astronomical observatories. Its main axis is meticulously aligned with the rising sun on the equinoxes. On these 2 days of the year, when day and night are of equal length, the first rays of the sun pierce the main doorway and travel down the central corridor, illuminating a specific stone slab deep within the sanctuary. But the builder's astronomical knowledge was even more refined. Another entrance at Mnajdra is perfectly oriented to capture the sunrise on the summer solstice, the longest day of the year, while a different alignment marks the winter solstice sunrise. Achieving this level of precision required centuries of patient observation of the sky's movements, a deep understanding of the solar cycle, and the engineering skill to translate that celestial knowledge into immutable stone. The temple itself became a giant calendar, its architecture ensuring that the cyclical rhythm of the cosmos was physically manifested within its walls each year, connecting the community's spiritual life directly to the fundamental order of the universe. The construction of these temples, with their astronomical alignments and massive slabs, speaks to a highly organized and socially complex society. Quarrying the large stones was just the first step. Using stone mauls and levers, workers would prise the limestone blocks from the bedrock. Transporting them to the site, even over relatively short distances, was a Herculean task likely accomplished with log rollers and ropes made from animal hide or plant fibers, pulled by large teams of people. The most sophisticated feat was the erection of the massive uprights and the placement of the even heavier lintels. This would have involved digging large pits, maneuvering the stones into position with levers, and then using a system of ramps made of earth and rubble to raise the horizontal slabs into place. The entire process was a communal, almost ceremonial act, a physical manifestation of a shared belief system. The dedication required to erect multiple temples across the Maltese Islands over centuries points to a stable, prosperous society, with a powerful priestly class capable of directing labor and resources toward these non-utilitarian, profoundly spiritual projects. The temples of Hagar Kim and Emnajdra are therefore far more than just ancient ruins. They are the sacred heart of a lost civilization, a permanent record of humanity's early quest to understand time, the cosmos, and our place within it, carved in soft stone that was made to last for the ages. And so we arrive at our final destination, a place that seems to push the very limits of what we believe was possible in the ancient world. In the Bekaa Valley of Lebanon stand the ruins of the Roman Temple of Jupiter at Baalbek, a site of staggering grandeur. But the Romans, master builders though they were merely the last in a long line of civilizations to build here. Their magnificent columns and carved friezes rest upon a foundation so colossal, so mind-bogglingly massive, that it has spawned one of the most enduring and perplexing engineering mysteries on Earth, the trilithon. This is a podium wall composed of 3 perfectly fitted limestone blocks, each one measuring an average of 64 feet in length, with a height of 14 feet and a depth of 12 feet. But these dry statistics fail to convey the sheer, visceral impact of their scale. To stand before them is to feel a profound sense of disbelief. Each of these stones weighs an estimated 800 tons. To put that almost incomprehensible weight into perspective, that is the equivalent of 2 fully loaded jumbo jets or 3 blue whales. The Romans built upon this foundation, but the staggering truth is that we have no idea who actually cut, moved, and placed these behemoths, or for what purpose. The trilithon represents a feat that seems to defy the physics and the technological capabilities of any known ancient culture. A puzzle that begins not at the temple, but nearly a mile away in the main quarry. Here, nestled at the base of the hill, lies the source of the mystery, a single, even larger stone, known as the Stone of the Pregnant Woman. This abandoned monolith makes the trilithon block seem almost manageable by comparison. It is 69 feet long, with a colossal 16-foot height and a width of over 14 feet, giving it an estimated weight of 1,200 tons. It remains partially attached to the bedrock, a silent witness to a project of such ambition that it was either abandoned or represents a level of technological prowess we have yet to fully comprehend. The quarrying process itself is a marvel, using techniques that likely involved carving channels and then driving in wooden wedges that were soaked with water to expand and fracture the stone. The unknown builders managed to free these multi-hundred-ton blocks from the earth with astonishingly clean, straight sides. The precision of the cuts, the sheer ambition to even attempt to move such masses, points to a civilization of master engineers whose names and methods have been utterly lost to time. The journey from the quarry to the temple site, a distance of nearly 3/4 of a mile, is the heart of the mystery. How do you transport a 1,000-ton block of stone across uneven ground? Every method we can conceive of with ancient technology seems to fall short. A standard theory for moving megaliths involves wooden sledges, log rollers, and vast teams of laborers. But the math quickly becomes a nightmare. The ground pressure exerted by an 800-ton block on a wooden sledge would have been immense, likely crushing any log rollers into splinters and sinking into the earth. Some researchers have suggested a system of wooden rails or a specially prepared roadway, but the coordination and materials required are staggering. To move such a weight, you would need a pulling force equivalent to thousands of people or hundreds of oxen, all coordinated with perfect synchronization. There is simply no physical evidence in the historical record for an operation of this scale anywhere else in the ancient world. This has led to more speculative theories, including the use of advanced levering systems, or even the controversial idea that the builders possessed a form of anti-gravity technology or acoustic levitation, concepts that remain firmly in the realm of legend and speculation due to a complete lack of evidence. Once these stones arrived at the Temple Mound, the final, and perhaps most baffling, challenge remained: lifting them. The trilithon stones were not simply laid on the ground. They were hoisted over 20 feet in the air and placed with hairline precision onto the second course of the podium. The precision of their placement is as incredible as their weight. The joints between them are so tight that, like the finest Inca masonry, you cannot slip a razor blade between them. How was this achieved? The conventional Roman method for lifting heavy stones involved massive wooden cranes powered by human-operated tread wheels, but the lifting capacity of even the most sophisticated Roman crane is estimated to be only a fraction of what would be needed for an 800-ton block. The use of enormous earthen ramps is a possibility, but constructing a ramp stable and large enough to drag a block of this weight to such a height would have been a construction project in itself, requiring more material than the temple complex above it. The entire process quarrying, transport, and placement remains an enigma that challenges our fundamental understanding of ancient engineering and forces us to reconsider the technological capabilities of a lost civilization that walked the earth long before the Romans ever laid claim to this sacred ground. The Trilithon of Baalbek stands as our final, and perhaps most humbling, monument. It is a permanent question mark carved in stone, a silent challenge from our distant past that continues to defy explanation. After exploring 30 of these magnificent structures, each a testament to its own unique culture and time, a fascinating pattern begins to emerge from the dust of ages. It's a pattern not of a single, lost global blueprint, but of a shared human genius, a universal toolkit of the mind that allowed civilizations separated by oceans and millennia to arrive at strikingly similar solutions for moving mountains of stone. When you look past the distinct forms of the pyramids, the zigzag walls, and the subterranean cities, you find a common foundation built on a handful of brilliant, yet fundamentally simple, physical principles. The ramp, the lever, the roller, and the pulley, these were the four cornerstones of ancient megalithic construction, the elemental technologies that, when combined with vast, coordinated human effort, made the impossible achievable. Consider the humble ramp, an invention so basic a child might build one in a sandbox, yet it was the key to reaching the heavens. From the spiraling earthen inclines that encased the rising pyramids of Egypt and the temples of Tikal, to the massive embankments used to raise the columns of the Parthenon and the stones of Sacsayhuaman, the ramp was the great equalizer. It transformed the insurmountable vertical challenge of lifting a multi-ton block into a manageable, if grueling, horizontal haul. The lever, too, was a global constant. Whether it was Inca stonemasons using wooden crowbars to make microscopic adjustments to a 100-ton puzzle piece, or Roman engineers employing massive beams to pivot a column drum into its exact position, the principle of leveraging a small force over a long distance to move a great weight was understood and applied with masterful skill. Then there were the rollers, felled tree trunks, placed beneath a stone-laden sledge, turning soul-crushing friction into manageable rolling resistance. We see their likely use from the Moai transport roads of Easter Island to the pathways leading to Stonehenge and the Great Wall. And finally, the pulley, a later but revolutionary refinement, allowed force to be redirected and multiplied, enabling the Greeks and Romans to hoist marble entablatures and the builders of Derinkuyu to lift debris from their deepening city with far greater efficiency. These were not exotic secrets. They were the elegant, practical fruits of observing and harnessing the basic laws of physics. Beyond these physical tools, there existed a more profound intellectual toolkit that was just as widespread, a deep and sophisticated understanding of geometry, astronomy, and material science. The near-perfect cardinal alignment of the Great Pyramid of Giza and the Ziggurat of Ur was not a happy accident. It was the product of meticulous celestial observation, likely using the stars to find true north with astonishing accuracy. The builders of Stonehenge and Mnajdr did not randomly place their stones. They created precise astronomical calendars, aligning heel stones and doorways with the solstice sun to mark the cycles of the year. This celestial connection was a global obsession, a way of anchoring human ambition to the eternal rhythms of the cosmos. Geometry was their shared language for translating vision into reality. The Pythagorean theorem, though named for a later Greek, was demonstrably understood and applied by the Egyptians to create right angles, and by the Maya to proportion their towering temples. The intricate, interlocking stonework of the Inca and the perfect curves of the Roman arch are both testaments to a universal grasp of form, stress, and load distribution. They thought in shapes and angles, calculating proportions that ensured both beauty and stability, and they were master material scientists, constantly experimenting with and improving upon the world around them. The Romans didn't just use sand. They discovered that mixing their lime mortar with volcanic pozzolana ash created a concrete that could set underwater and last for millennia. The Chinese of the Ming Dynasty, in a stroke of culinary genius, found that adding sticky rice soup to their mortar produced a bond so strong it has helped the Great Wall resist centuries of erosion and even modern mechanical damage. The Sumerians, building on the floodplains of Mesopotamia with little stone, perfected the humble mud brick and then protected their ziggurats with a waterproof skin of bitumen. Each civilization looked to its local environment, identified the available resources, and then, through trial, error, and brilliance, engineered them into something far greater than the sum of their parts. What is perhaps most illuminating, however, is not just the common ground, but the fascinating divergences, the different philosophical paths taken to solve the same fundamental problem of building big and building to last. Look at the stone masonry of the Inca at Machu Picchu or Sacsayhuaman and compare it to that of the Egyptians at Giza. The Inca approach was one of intricate, patient fitting. They worked stone like a master woodworker, shaping each irregular block to form a unique, interlocking joint, creating flexible, earthquake-resistant walls without a drop of mortar. Their focus was on the perfection of the seam, the relationship between individual stones. The Egyptian approach, by contrast, was one of overwhelming mass and geometric precision. They used immense manpower to quarry and stack millions of standardized blocks, creating a rigid, monolithic form whose stability came from its sheer weight and perfect symmetry. One method valued flexibility and a symbiotic relationship with the dynamic earth. The other celebrated immutable permanence and the power to create a new, artificial mountain. One was a complex, three-dimensional jigsaw puzzle. The other was a colossal exercise in volume management. Both achieved immortality in stone, but they represent two profoundly different expressions of architectural genius, born from their unique environments, beliefs, and social structures. This global tapestry of techniques reveals a powerful truth about our ancestors. They were not primitive people stumbling in the dark. They were the world's first engineers, physicists, and astronomers, armed with sharp minds, keen observation, and an indomitable will. They understood that to conquer the landscape, they first had to understand it, to know which stone could be split with fire and water, which volcanic ash could make magical concrete, and how the sun's path could be locked into the alignment of a temple doorway. The story of these ancient megastructures is, at its core, a story of human intellect triumphing over physical limitation. It's a narrative that connects a quarry worker in Egypt dipping his copper chisel in water to a stonemason in Peru, patiently grinding a granite edge with sand, both part of a vast, unspoken global collaboration across time, all reaching for the sky with the same fundamental tools and the same boundless imagination. We have traveled a truly epic path together, from the shadow of the Great Pyramid to the hidden depths of Derinkuyu, from the mathematical perfection of the Parthenon to the cosmic calendar of Chichen Itza. We have seen 30 breathtaking testaments to a time when human ambition was carved in stone on a scale that still defies belief. This journey reveals something far more profound than a simple list of architectural marvels. It uncovers a universal truth about our species. Across every continent, in every climate, and with every conceivable set of resources, our ancestors shared a common, unyielding drive to reach for the impossible. They looked at a mountain and saw a temple, at a river and saw a challenge to be mastered, and at the stars and saw a map to be followed. This was not the work of aliens or lost super-civilizations, but of human beings, people with the same cognitive capacity as you and me, armed with an intimate knowledge of their environment, an unparalleled mastery of simple physics, and a breathtaking capacity for coordinated effort. They were the ultimate problem solvers, leveraging the basic principles of the ramp, the lever, and the roller to move mountains, literally and figuratively, creating legacies meant to last for eternity. What resonates most powerfully, perhaps, is the sheer diversity of intelligence on display. We saw the administrative genius of the Egyptians, who coordinated tens of thousands of workers with the precision of a modern corporation, all without a single smartphone or spreadsheet. We witnessed the artistic and astronomical genius of the Maya, who encoded their entire understanding of cosmic cycles into the very steps of their pyramids. We marveled at the earthquake-defying engineering of the Inca, who understood that a wall must be able to dance with the earth rather than stand rigidly against it. From the celestial observatories of Mnajdra to the subterranean urban planning of the Indus Valley, each civilization applied its unique intellect to a shared set of human desires: to honor the divine, to protect the community, to understand the cosmos, and to leave a mark that shouted, "We were here." Their achievements stand not as isolated miracles, but as a chorus of human potential, a global symphony of ingenuity composed over thousands of years. And this leads us to a final, reflective question, one that these silent stones seem to ask of our own hurried, technologically saturated world. With all of our computational power, our advanced materials, and our global networks, what profound capabilities of the human spirit might we be overlooking? We have optimized for speed and efficiency, but have we lost something of the patient, generational perspective that saw a project like the Lushan giant Buddha through 90 years of continuous labor? We celebrate individual genius, but do we undervalue the kind of deep, communal collaboration that could move an 800-ton stone at Baalbek or coordinate the entire population of an island to erect the Moai? Our ancestors teach us that the most powerful technology is not always the most complex one. It is the perfectly applied one. It is the human mind observing a problem, the collective will of a community to solve it, and the unwavering persistence to see it through, even if it takes a century. They remind us that intellect, when fused with collaboration and a deep connection to purpose, is the most powerful tool ever forged. As we bring this exploration to a close, we'd love to hear which of these ancient wonders captured your imagination most powerfully. Was it the haunting isolation of the Moai on Easter Island, the impossible precision of Sacsayhuaman's walls, or the serene, colossal gaze of the Lushan giant Buddha? Let us know in the comments below which site you would most want to visit, and why sharing these stories is what keeps the legacy of these ancient builders alive. If you enjoyed this journey into the depths of history's greatest mysteries, please subscribe to the channel. We have so many more incredible stories to share, from lost cities and sunken civilizations to the untold secrets of the ancient world. Thank you for watching, and never stop exploring.